Hi, in this video, we will talk about interface in Java. Okay, what is interface? So when you see, an interface defines a contract that a class needs to conform to. Means an interface is a contract, or you can say a kind of template, and a class has to follow this contract or this template. So that is called interface. An interface defines a list of methods that need to be implemented but does not define the methods implementation. So an interface will have multiple methods. Okay, list of methods means multiple methods it may contain, and those are not implemented. Okay, those are empty methods, those are not implemented. How we write in the abstract classes, we will write abstract methods, right? The same way. An interface needs to be declared using the interface keyword. So how you define an interface, right? For that, we have one of the keywords called interface. We need to use that keyword to define an interface. Methods of an interface are always public. Okay, all the methods, whatever you write inside the interface should be public. Why these methods should be public? The reason is we will not have any implementation for these methods. We need to implement these methods in another class. So if you want to access these methods to another class, then these should be public visibility. Then only other classes can access these methods. Because of that, these are public. In the class definition, we need to use implements keyword to implement the interface. So implements also used to kind of what you say inheritance, but in inheritance we will use extends. Means for the class you will use extends, for an interface you need to use implements. That is the difference. Interface is pure abstract class. So what do you mean by pure abstract class? When you talk about abstract class may contain both abstract methods and concrete methods, but in interface you cannot write concrete methods, only abstract methods. Because of that, interface is pure abstract class. Okay, if you go back and revisit abstract class, abstract methods, then you will see the difference between these two. Abstract class abstract class may contain concrete methods and abstract methods, but in interface you will have only abstract methods. So can achieve multiple inheritance using interface. So in our previous videos we discussed that multiple inheritance is not possible in Java using classes, but with the help of interfaces you can achieve multiple inheritance. So in our next videos we will see this topic. Okay, so we'll take an example and understand what exactly interface, how it will work. So for this, let me go to Visual Studio Code. So here I created one interface called Maruti. Okay, so normally how the class will be like this, class Maruti. But if you want to represent an interface, instead of class you need to use interface. Okay, so inside that you will have multiple methods according to your requirement. So let me write few methods. I'll write void engine capacity, and you need to terminate here itself. You do not have any implementation. And another one is void wheels, something like this. Okay, so let me just compile this one. So where I am, let me go to this interface demo, copy path. Okay, so Java C Maruti.java. So no problem, right? Nothing. So now what we'll do, how we did inheritance means we have created a class and we used extends keyword and we achieved inheritance. The same way you can do here also. And abstract class means you need to extend and you need to implement all the unimplemented methods inside the abstract class. But here, each and every method you need to implement. The reason is all methods are abstract methods in the interface. Okay, let me copy this. When you go to auto.java, sorry, public void engine capacity, I will write system.out.println something like 1000 cc vehicle or car, whatever it is. Okay, this is fine, but from where this method is coming? Right, this method has to come from Maruti, right? But how you'll get this one? If I say extends Maruti, okay, and let me compile this now. You see that error, no interface expected here, also extends Maruti, also extends Maruti. Here you have used Maruti, but you are using extends. Extends means you need to extend a class, but Maruti is an interface. So it is what it is saying, no interface expected here. Here I'm expecting class. The reason is you used extends. Okay, so if you want to inherit an interface, you need to use implements. Another keyword called implements. Okay, for an interface, you need to use implements. For a class, you need to use extends. And Maruti is an interface, so you need to use implements. So go again and try to compile this. You see that? Also is, alto is not abstract and does not override abstract method wheels in Maruti. So this is not an abstract class. Abstract means you may have unimplemented methods, but this is a class. You need to implement everything, whatever you have written inside the interface. So because of that, it is saying error related to Maruti. So what I need to do, I need to implement this one also. Public void so now system.out.println and then wheels, I say 4-wheel vehicle, something like that. Okay, so I implemented wheels also. Now if you compile this one, you will not get any error. You see that it compiled successfully. Apart from these things, you might have your own, right? Public void, what do you say, AC option, something like that. Right, this is a concrete class. So let me copy here from here. I can implement whatever I want. Non-AC vehicle, something like that. Right. If you compile, now also no problem. Right. You have to implement these methods. The reason is you are implementing Maruti. Right. And I'll try to implement same things in the Balin also. Okay. I can say this is something like the 1200 cc and this is AC vehicle. Here also I need to implements Maruti. Right. If I go here and Java C baleno.java, it will compile, no problem. Okay. So this is how you can create an interface you will have some template, means you have to implement these methods when you implement this Marut. So I implemented this interface. So I have to implement these two methods which are there inside the interface. Same way, these two methods. Apart from this concrete class can contain another methods or may not. So now I'll try to create an object and execute. Okay. So here alto a is equals to new alto and a dot engine capacity, a dot wheels, a dot AC option. And the same way I can say Baleno B is equals to new and B dot engine capacity, B dot wheels, B dot AC option. All right, that's all. So go back here, Java C vehicle dot Java, compiled successfully, Java vehicle. You see that I'm getting all the output. These three are related to Alto, these three related to Baleno. Right. This is how you can create an interface like this, interface and the interface name and all unimplemented methods. Okay. And here I implemented all these methods. And here also all the methods are implemented as I implementing this one. And I need to, I created an object and executed successfully. Okay. So this is how you need to explain an interface. Okay. So let me go back to the PPT. What could be the possible interview questions? What is an interface in Java? What is abstract class in Java? Difference between abstract class and interface. Okay. So we will see difference between abstract class and interface in our next video. And apart from that, what is the advantage when you use interface? You can achieve multiple inheritance. So after that, we will see how we can achieve multiple inheritance using interface. Okay. That's all in this video. Thank you. Hi. In this video, we will see the difference between abstract versus interface. Okay, abstract class versus interface. So when you talk about abstract class and interface, you see that here. Let me. So here, abstract class can extend only one class. Okay, so classes we cannot extend more than one class. We already saw. Because of that, multiple inheritance is not possible. So interface can extend any number of interfaces at a time. Okay, an interface can extend another interface. Abstract class can extend another concrete class or abstract class. So if this is an abstract class, it can extend another abstract class or concrete class. Right. But coming to the interface, interface can only extend another interface, not classes. Okay. Abstract class can have both abstract and concrete methods. Right. Interface can have only abstract methods. This is the important difference, right? The moment when you talk about anywhere abstract class and interface, abstract class can contain both abstract and concrete methods. But coming to the interface, it has only abstract methods. Because of that, interface is pure abstract class. Okay, pure abstract class. And then abstract keyword is mandatory to declare a method as abstract. The reason is here you will have abstract methods and concrete methods. So to make the differentiate between these two, you have to use abstract keyword here is mandatory. But here abstract keyword is optional to declare a method as abstract. The reason is all methods inside the interface. Okay, all methods in the interface are abstract only. Because of that, this abstract keyword is not mandatory. abstract class can have protected and public abstract methods, but interface can have only public abstract methods. Abstract class can have static final or static final variable with any access modifier, but interface can only have public static final variable. Okay. So this is how you need to explain the difference between abstract class and interface. Okay. So these are all the basic differences between these two. Let me clear this. So what could be the possible interview questions from here? What is an interface in Java? What is abstract class in Java? Then what is the difference between abstract class and interface? Okay, that's all in this video. Thank you. Hi, in this video, we will see how Java supports multiple inheritance. In our previous videos, we discussed that Java will not support multiple inheritance. But for that purpose, we can use interfaces to achieve the multiple inheritance in Java. So by taking an example, we will see how we can achieve multiple inheritance using interfaces. Let me go to Visual Studio Code. So here, I created one interface called interface E. Okay, and another interface called interface B. Okay, then we'll have some methods inside this. What is that? Public void method. This is one. Public void method E. Okay, I have two abstract methods inside the interface. Interface A. This is just a name. Okay, you can give whatever it is, but this is an interface. Here in the interface B, public void, again a method, and public void method B. Okay, here I have two abstract methods. Here I have two abstract methods, but here the common method is method, and here also method. Okay, so if you talk about this thing previously, what we discussed, if you have two classes, means two concrete classes, this is A and this is B, and if it is C, if you have method here and if you have method here, if you try to achieve multiple inheritance, means both the parents, then if you call C dot method, then which class it has to, means which method it has to access from which class. This method, from which class it has to access. Here also method, here also method. Right. If it is pure abstract classes and if you use extends. Right. Because of that, we discussed multiple inheritance is not possible here. But when it comes to the interface, you have a interface A, interface B, and you have a class C. Right. In the interface, you have method, and here also you have method. But here there is no implementation. Here there is no implementation because these are abstract methods. Right. These are abstract methods. So when you try to, if you implement these interfaces, okay, if you use these interfaces, both interfaces, you have to implement these methods. So you will implement this method. So like this. Okay, you will have something like this. So then you implemented this method. When you create an object and C dot method, how you do like this way, but here you implemented this method itself in the C class. So normally it will get this method, right? When you call a method, it will search in its own class whether I have this method or not. If that method is there, it will try to execute that. If it is not there, then it will search for the parent. But here there is no need to go to parent. You have that method itself inside the class. Then you can execute. But from where it came, from interface A or B, we don't bother about that. So whatever it is, so A feels that okay, it implemented method. B also feels that it implemented method. this will not complain anything. This method is not from my interface. This method is not from my interface. A and B will not complain like that. A will look into this. Okay, method is there, so it is implemented. B also looks into this. Okay, method is implemented. That's it. Okay. So now, because of this, we can achieve multiple inheritance. So now we have the method here and method here. So now I created one class. So public class C. Okay. Inside this public static void main string args. So now if I try to implement both, okay, if I try to implement both interfaces, implements interface A comma interface B. Okay, so I'll try to compile this first. Okay, you go here. I am inside this Java C interface A dot Java. So no issues. Java C interface B dot Java. So I already compiled both the parent. Now I'll try to compile Java C class C dot Java. What it is saying? Class C is public, should be declared in a file name. Sorry, class C. Okay, 1 second. So you need to mention this class, right? So public class C implements interface A comma interface B. So previously when I say extends class A comma class B, here itself I got an error. Okay, so now what will happen, we'll see. Again, why it is coming? Sorry, this class is capital C. Too many typos. Okay, so again we'll try to compile. It should not give any errors. Okay, now what it is saying? Class C is not abstract and does not override abstract method A in interface A. So you need to implement these things. The reason is you are implementing, but it is not complaining about why you're writing 2 with a comma, right? So for that, what we need to do, we need to implement those methods. Public void method system.out.println. This is which class method? I don't know, A or B interface method. We don't bother about that. Okay. So class interface A will feel that method is implemented from interface A. Interface B feels that method is implemented from interface B. These two interfaces will not complain. The reason is it is seeing method inside this class where it is implemented. Okay. So now I'll copy these things. Method A. Okay. A from interface A. Here method B. So B from interface B. Okay, that's all. Interface B. So now I implemented everything. If you try to compile now, it will not give you any issues. You see that? No issues. But we need to call these methods, right, by creating an object to class C. So I'll say class C is equals to new class C dot method C dot method A C dot method B. So here C dot method means from which interface it is coming. We don't bother about all those things. The reason is this method is implemented inside this class this is local, means local to this class. So when you call c dot method, it will search in its own class. I have a method inside my class or not. Yes, it is there. It will call from here. And interface A feels that this method implemented in the C class. And the same way interface B also feels that this method is implemented in this class. And class C will directly access the method from here. So no issues. This is how you achieve multiple inheritance. Now we'll try to compile again and we'll try to run. Okay, compile Java class C. You see that I'm getting all the output. A or B interface method, A from interface A, B from interface B. Right. We achieved multiple inheritance. I'm able to put a comma and I can implement more than one interface here. Okay. So this is how you can achieve multiple inheritance in Java using interfaces. So what could be the possible interview questions? What is an interface in Java? How Java supports multiple inheritance? You can give this example and you can explain. Okay. So that's all in this video. Thank you. Hi. In this video, we will see polymorphism in Java. So what is polymorphism in Java? So polymorphism is the ability by which we can create functions or reference variables which behaves differently in different programming context. Okay. So the ability is that the methods and variables will differ in different way according to the context. That in simple words, it allows us to perform single action in different ways. Okay, single action in different ways. So by taking an example, we'll see all these things. But in theory, so the simple thing is it allows us to perform single action in different ways. So there are two types of polymorphism. So one is, what is that? Compile time polymorphism, that is called static binding or method overloading. So another one is runtime polymorphism, that is called dynamic binding or method overloading. So three names for each. So compile time polymorphism or static binding or method overloading. And the second one is runtime polymorphism or dynamic binding or method overriding. Okay. So what do you mean by compile time polymorphism? This is used to write the program in such a way that flow of control is decided in compile time itself. Okay, flow of the control will be decided in the compile time itself. It is achieving using method overloading. Compile time polymorphism can be achieved using method overloading, and the flow of your program execution will be decided at compile time. Because of that, it is called compile time polymorphism. In method overloading, an object can have two or more methods with the same name. Okay, an object can have two or more methods with the same name, but with their method parameters are different. So method parameters might be different in this scenario. These parameters may be different in two bases. That is, one is parameter type and parameter count. Okay, we are saying the difference in the parameters. The difference will be in the form of parameter type or parameter count. This is called compile time polymorphism. So what is runtime polymorphism? So runtime polymorphism is essentially referred as method overriding. Method overriding is a feature which you get when you implement inheritance in your program. Okay, the method overriding you will get when you have inheritance implemented. Right. Okay. So in our next videos, we will discuss about method overloading and method overriding separately, exclusively on those things. Okay. Here we have seen only theory part of polymorphism. So what could be the possible interview questions from this? What is polymorphism? What is method overloading? What is method overriding? What is the difference between these two? Okay. We will see all these things in our upcoming videos. Method overloading as a separate video, method overriding as a separate video, and the difference between these two things as a separate video we will discuss in our next videos. Okay, that's all in this video. Thank you. Hi, in this video, we will discuss about method overloading in Java. So this is called compile time polymorphism. So the theory which we already discussed in our previous video. So exclusively we'll discuss about method overloading in this video. So if a class has multiple methods with the same name, but different parameters called method overloading. Okay. You have a class, inside the class, you have more than one method with the same name, but different parameters is called method overloading. Method overloading increases the readability of the program. So you will not get confused with the methods when you look into that. So we'll easily understand what exactly the method is for. Okay. So different ways to overload a method. Okay. We cannot simply overload a method. There are some rules. So we'll see by chaining the number of parameters, by chaining the data type of parameters. Sorry, changing, not chaining. By changing the number of parameters, by changing the data type of parameters, by changing the order of data types of parameters. These three ways you can achieve method overloading in Java. Okay, so we'll see one by one with one example. So let me go to Visual Studio Code. So here I created one class called method overloading demo1, MO demo1. And here we are going to discuss about by changing the number of parameters. Okay, so here I'll create one method called public void add. Simple method add. Inside this, system dot out dot println, I'll say addition. Simply I'm printing addition. So I'll create one more method with the same name. Okay, with the same name. So here I'm just adding numbers. Okay, now I'll create main method public static void main string aux. Okay, I'll create object m is equals to demo1 and m dot add. Okay, so I created two methods with the same name, and I'm trying to access, means execute that method using the object. Okay, so now what happens? Right here, you are calling m dot add. I have two add methods, this one and this one. Now, which method it has to access? Which add? This add or this add? That is the problem. It will get confused that which add method I need to execute. So because of that, you will get error at compile time only. Okay, compile time only you'll get the error. So if it is any IDE, means Eclipse or IntelliJ IDEA, then the moment when you create like this, immediately it will throw an error. It will show error before you execute itself. That is one of the features of IDE. But here we are using text editor, right? So we are not using any IDE. We are using text editor, that is VS Code. So until you compile, you will not come to know what is the issue. Okay. So first we'll try to compile this and we'll understand what is the problem, then how we can resolve that. So let me clear this. Now, if I go here and I try to Java C mo demo1.java, you see that method add is already defined in class mo demo1, right? So this method is already defined. Why are you defining again? Right. So now I cannot do like this. But I want to do the same thing. How you can do that? Sorry, let me copy again. So now, by changing the number of parameters, here how many parameters are there? Nothing. But here I can put some parameters. Int a comma int b. Okay. Now what I'm doing here, I'll just print these things. A plus, sorry, I will add and I'll print a plus b. Right. Here what is happening? This is add. This method name is also add. But where it is different, so differ from this method, this add to this add, the parameters. Right. By changing the number of parameters. Here 0 parameters, here 2 parameters. You might have 1 parameter here, 2 parameters here. You might have 3 parameters here, 2 parameters here. Until unless both are having same number of parameters and same order and same data type, you can do any, you can create how many methods with the same name you can do. But if both are same exact, then it will not allow. So if I try to execute this now, okay, it will compile simply, no problem. The reason is no issue. I can even execute also. You see addition. The reason is if you say add, so matching method is there. What this method it is matching, it will come. If you want to call this method, you need to do m dot add of 10, 20. Right. So how many parameters and which parameters it is expecting, we need to pass those. So if I try to execute now, you see that addition and 30, 10 plus 20, 30. Right. Both methods should not be same exactly. Okay, signature, we can say signature. So the signature should not match. Here public, void, add, same thing. Then why you need 2 methods? If you want to type, print this one also, you can write here. Just because of this implementation, why to create the same method with the same name? Right. So this is how, by changing the number of parameters. You can put another one int a. So now if you can put 100, no problem. You can execute 1 parameter, 2 parameters. You can have multiple parameters more than, but if you say int c, okay, say int c 100 comma 200. This time also you'll get an error, both are same, right? This method is already defined in the class. I mentioned AC here, but AB here. People will get confused like that, but this is just a name. Whether you put A, B, C, whatever name you want, that is just a name, but we need to bother about, here we are passing 2 integers, here also we are passing 2 integers, then both are same, it will not allow. So right, so this is how, by changing the number of parameters, you can achieve the method overloading. Now I overloaded add method here with these 2 parameters. Okay, same method with different parameters. That is called method overloading. This is one way. The second one, second point. What is that? By changing the data type of parameters. By changing the data type of parameters. So let me create the same public void add. Okay. Here what I'm adding, int a, comma, int b. Sorry. What I'm doing, system dot out dot print ln a plus b. Okay. And I'll take the same thing, same name, sorry, same method. But what I'm saying here, changing the data type of parameters. So I'll change to string. Right, string. Here also a plus b. I'm concatenating these two strings. Now, public static void main string args. So I'll create MO demo2. M is equals to new MO demo2 m dot add. What is that I'm doing? 10 comma 20 m dot add. I need to pass two strings. Krishna second. Okay. So now you'll not get any issue. The reason is previously we said both should not be the same. Here two parameters, here two parameters, that is an issue. But here same name, same number of parameters, but the data type is different. Here I'm passing integers, here I'm passing strings. So because of this change, we can override a method. So add, right? If you try to execute this, no issues, it will execute. You see the 30, 10 plus 20, 30, Krishna second, it is up concatenating and giving the result. So this is how you can achieve by changing the data type of parameters. Not only string, you can give string int string. But that we can see by changing the data type of parameters. Here I passed integers, here I pass strings. Because of that, the number of parameters are same here also and here also. But the data type is different. Because of that, it will allow method overloading. Okay. And we'll talk about the third point. By changing the order of data types of parameters. Now, let me take everything instead of writing again. I'll modify according to that. So this is demo 3. Okay. Now the same add, but here string B. Here int E. Okay. So now what I'm doing? Same number of parameters, same type of int A. This is string A int B. Okay. So same name, same number of parameters, same type of parameters, but we changed order. Here integer the first parameter, but in this integer is second parameter. Here string is second parameter. Here the string is first parameter. So this order has changed. If the order did not change, then it is duplicate of this method. Right? It will not allow. So because of that, we can achieve the method overloading by changing the order of data types. Okay. So if I try to print 007, I'll say James Bond. So here also one parameter I need to pass 007, the string James Bond. So this will match with integer and string. So this it will execute. This one will match this method, it will execute. First parameter is string, second parameter is integer. Okay, we'll try to execute. You see that 7 James Bond 7, concatenating and giving. Okay, you can use concatenation between string and another data type. Okay, so here how we achieved method overloading, same method, same number of parameters, but the order is different. Order of data types of parameters by changing. Okay, this way also you can achieve method overloading. Okay, so if you go to the PPT, so we have seen all these three things by changing the number of parameters, changing the data type of parameters, changing the order of data types of parameters. Okay. So what could be the possible interview questions from here? What is method overloading in Java? How many ways we can achieve method overloading in Java? Okay, that's all in this video. Thank you. Hi, in this video, we will see method overriding in Java. So what is method overriding? So this is, we have seen like what is method overriding? Dynamic binding, right? So runtime polymorphism. So if subclass has the same method as declared in the superclass is known as method overriding. So if you want to achieve method overriding, you should have at least two classes and you should have a relation between these two by taking extends keyword, means you need to implement inheritance. So in the superclass and subclass, both having the same method name, that is called method overriding. For example, if subclass provides the specific implementation of the method that has been provided by one of its parent class is known as method overriding. You have a method in parent class and the same method you have in child class, and you have a different implementation for that. Okay, that is called method overriding. Method overriding is used to provide specific implementation of a method that is already provided by its parent class. Right? You'll have your own implementation for that method. Because of that, you will override the method. Method overriding is used for runtime polymorphism. Methods must have same name as in the parent class. The signature should be same. Method must have same parameters as in the parent class. Same name, same parameters, everything should be same in both the classes. That is called method overriding, but the implementation for these two methods will be different. So advantage of method overriding is that the class can give its own specific implementation to an inherited method without even changing the parent class code. Okay, that is the advantage. So by taking one example, we will see, then it will be very clear. So let me go to Visual Studio Code. I created one class called public class Maruti. So inside this, I have a method public void seats. Okay. So system dot out dot println. So this is 5-seater vehicle. That is how I implemented. Okay, in this class. There is a class called Maruti. Inside that we have a method called seats. The implementation is what? 5-seater vehicle. Now, I created one more class called Ertiga. This is one of the models of Maruti. And here, if you want to override a method, we should have a relation between these two things, means these two classes. That is called inheritance extends Maruti. Okay. So here, I have same public void seats. Right. Here also seats. Here also seats. When you extend, automatically you can use this method. Right. But again, why you need this method? Okay. So first what we'll do, we'll create public static void main method string args. So I'll create Ertiga E is equals to new Ertiga E dot seats. Okay. So for some time, you just comment this code. Okay. Now we'll try to execute what happens. Right. The seats is from, I need to get it from the Maruti class. This is my parent class. I'll get everything which is public. No, we can get here. Right. Go to Java. See, first I need to compile Maruti dot Java. So it will compile, no problem. Now Java Ertiga dot Java. I'll run this one. You see that 5-seater vehicle. So I can get all the properties of my parent class. So the same way I got the seats method, I can execute here. But because of some reasons, I need the same method name, but a different implementation. I have my own logic. Okay, I should have my own logic. So that time you will override the method with your what? Your own implementation. What is that? My implementation system.out.println. This is 7-seater vehicle. Ertiga is 7-seater vehicle. I don't want that implementation 5-seater. It's I have my own implementation for this. That is 7-seater vehicle. So now when you execute like this, first preference will go to its own class. So it will verify whether seats are available. When seats method is available in my class. Yes, it is there, it will execute. If it is not found in this class, then it will go to its parent class. So we'll try to execute this now. We'll see. Now it should print 7-seater vehicle. See, 7-seater vehicle. So because I have this one and I overridden that class, sorry, method. This method I have overridden in this with different implementation. If I want, if it is 5-seater vehicle, then why to write again this one? I already have here, right? I can directly call. I don't need, but it will have its own implementation, separate logic, its own logic. So because of that, you will override the method. Okay, but now I want to access this method also. Okay, that time what you can do simply you can create an object to that new Maruti and m.seats. Simple. With the help of its object, I can call. So if you try to execute this, it will print 7-seater and 5-seater. But in one of our previous videos, we discussed about super keyword, right? So if you have a inheritance, you have parent class methods. If you want to call, that time you can use super keyword, simply super.seats. That's it. No need to create an object, all these things. Super means it refers to parent class object. So if you try to execute now, I'll get the same output. You see, first 5-seater, the reason is we are calling this first one. Okay, so this is how you can override the methods. Method already available in your parent class with some implementation, but in your class you want same method but different implementation, then you can override the method, no problem. So if you want to access parent class this same method, you can use super keyword. Okay, so this is how you can achieve runtime polymorphism. Okay, if you go back to your PPT, what could be the possible interview questions? What is method overriding and how to achieve overriding in Java? Okay, that's all in this video. Thank you. Hi, in this video, we'll talk about difference between method overloading and method overriding. So what is the difference between these two things? Okay, so when you talk about method overloading and method overriding differences, so overloading happens at compile time. So because of that, it is called compile time polymorphism. So overriding happens at runtime. Because of that, it is called runtime polymorphism. So static methods can be overloaded, which means a class can have more than one static method of same name. But you know the rules, right? The argument should be different. Okay, data type should be different, or the order should be different. Those are applicable, but static methods can be overloaded, which means can have more than one static method of same name, right? So here static methods cannot be overridden. Even if you declare a same static method in child class, it has nothing to do with same method of parent class. So static is only applicable to the class. We need to, if you want to access, it will be with the class name, right? Nothing to do with object. So overloading is being done in the same class, right? Overloading means in the same class, multiple methods with the same name, with the different arguments, all these things. So it will be in the same class. But if you want to achieve or do overriding, it requires two classes, that is base class and child class. Overriding is all about giving a specific implementation to the inherited method of parent class. Right? You have two classes, parent and child, and both the classes you have a same method. So, but both the methods will have their own implementation, different implementation. Because of that only we'll use overriding concept. Static binding is being used for overloaded methods. Dynamic binding is being used for overridden methods. Because of that, we have already said this is static binding and this is dynamic binding. Okay. So now we'll see some more. So here also, a written type of method does not matter. In case of method overloading, it can be same of different. Means you don't bother about return type. You just bother about the method name and different parameters. Overriding method can have more specific return type. Okay. Here everything should be same, right? Exact replica you should use. Argument list should be different while doing method overloading, but here argument list should be same. It should be different, but here it should be same. The reason it should be replica of your parent class. Okay. So the parent class, child class should have the same method, but the logic inside the method should be different. Okay. So private and final methods can be overloaded. The reason is it is happening in the same class, right? We are doing it is same class. If we have a private method, so that is accessible inside the same class. So if you have multiple private methods with the same name, so private and final methods can be overloaded. Private and final methods cannot be overridden. Private itself is what? Restricted to that class. Okay, restricted to the class. So if you inherit, if you use extends keyword and if you inherit also, you cannot access private method. So how you can override that? Right, you cannot override private. Okay, so private and final methods cannot override. So these are all the difference between method overloading and method overriding. Okay, so what could be the possible interview questions from this? So what is the difference between method overloading and method overriding, and what is method overloading and what is method overriding? Okay, these type of questions you may face, difference between these two things and a separate things. Okay, that's all in this video. Thank you. Hi, in this video, we will talk about final keyword in Java. So what do you mean by final keyword in Java? So the final keyword in Java is used to restrict the usage or modification by other classes or variables. Okay, so using this keyword, one tells the interpreter not to allow any future modification to that variable or method and treat it as constant. So if you have a variable, so if you want to restrict that not to change in the future, then you can make it as a final. And you have a method, you should have any restricted access to that method, then you can use final. So in which scenarios we'll use final? So we'll discuss about that in 3 scenarios. At the variable level, at methods level, at classes level, you can use this final keyword. So what do you mean by final variable? So to create a constant variables and modification not allowed on that variable. So if you create a variable, if you do not want to change that variable value in the future, then you can make it as a final. Let's take an example in the mathematics pi. Pi value is constant. If you should not change that. Okay, so that value you can make it as a final, then nobody can change that value. And the same way for methods, declaring a method as final restricts method overriding of that method in the child classes. You have a parent class. In the parent class, you have some methods. In the child class, you can override in normal way. But if you do not want to override some of the methods from the parent class, then make them final. Then child classes cannot override those methods. So classes, declaring a class as final prevents the inheritance of that class. You have a class and you don't want anybody to inherit that class. So make that class as final, so nobody can inherit that class. Okay. So these three things, by taking one example, we'll see. So let me go to Visual Studio Code. So I have created three classes: final variable demo, final method demo, final class demo. We'll take one by one and we'll see. So first take an example of int num is equals to 10. Okay. Then write system.out.println. I'll print the number. So after this line, I will assign another value to the same variable num. And again, system.out.println, I'll print num. Okay. So here it will print 10, but in this line, I reassigned some other value to the number. So 20. So then the I value is 20. Now you'll get 20 here. Okay. So we'll try to execute and see what happens. Java say it executed. You see that 10, 20 printing. Okay. So, but this number value, you should not change in your program or somewhere after initializing like this. You initialize and then assign some value to this. And in the future, you don't want to change the value of this num from 10 to some value. Here I made it 20, but I don't want to do this. I want to restrict like this. Okay. So then make it final. Final is a keyword. Make it final. Final int num is equals to 10. Then if you try to compile this now, you see that at the compile time only you got an error saying error cannot assign a value to final variable num. Okay, you cannot assign a value to the final variable. Right. Now nobody can change like this. You cannot change like this. Num is equals to num plus some 30, something like this. Whatever it is, we cannot do all these things. Okay. So this is the final keyword at variable level. Okay. Now, if it is final, it will throw an error. What is that error? You cannot assign a value to final variable num. Okay. So we'll take another example for method. We are discussing we cannot override if you declare as a final. So override means there should be inheritance concept. If you want to use inheritance concept, you need at least two classes. So let me create another class. Class, I say parent. Inside this, I have a public void. Just take an example method. And system.out.println. Then I'll say parent class method. Okay. So here I will override that. Before that, I need to extend this parent class. Okay. So then I will try to override, means I'll take as it is and I copy paste. So I overridden this method. So now I'll create an object to this class and I'll call that method. It's quite simple. We already saw in polymorphism. So what is method overriding? So we did the same thing. So the same method in the parent class, I'm using the same method. So now if you call this one, automatically it will call this local class method as a priority. Okay, let me execute this and we'll see what happens. You'll not find any issues. And it will print parent class. Sorry, I need to change this to, I'll just change this. So then we'll see the exact output, means the difference. You see that we have overridden. So we changed our implementation. So I have my own implementation in this class. So I'm able to execute this logic. But I don't want to override this method. I want to restrict not to override this method from this parent class. Then what you can do, you just make it final. Okay, public final void. I added this final keyword. Okay, now if you try to compile this, you see that method in final method demo cannot override method in parent. Overridden method is final. Okay, you cannot do this. Okay, overridden method is whatever the method you overridden, that is a final in this parent class. So you cannot override the class. But this is how you can restrict. That is the advantage of final. In some reasons, if you do not want to override any methods, then make them final. But this is another usage of final. So the third one. So the third one, final class demo. So what I'll do, I'll take the same example. Let me copy paste everything. Okay, so I took the same thing and change this final. This is not final. Okay, now no issues, right? Simple overriding. Then we can simply execute Java C .java. No issues. What happened? Duplicate class. Sorry, I did not extend parent. So I forgot to extend that. Sorry, I need to execute final class demo. Again, duplicate class parent, final method demo. So what mistake we did? Okay, this is I have copy pasted. I need to change this. So typo issues. So let me execute again. Let me compile. This is no issues. Java final class demo. This is the tail class method. So whatever we did with same thing we did, I removed the final, and this is quite simple. But I don't want to extend this class. I don't allow somebody to extend this parent class. Here I extended, right? But I don't want to extend this class. So then make the class as final class. So final class. Then I did not use any final here. So I can override in normal scenario. But when I make it final, you observe the behavior. You see that error cannot inherit from final parent. You see, cannot inherit the final parent, and where it is showing extends parent here. So if you do not want to extend your class to some other class, then make the class as final. Then nobody can extend that class. Okay, using final keyword. This is another usage of final keyword. Okay, so we have seen final variable. If you make it a variable final, you cannot change the value. Okay, final method, if you make a method as final, so you cannot override in your child class. If you make a class as final, you cannot override that class. Okay, so this is the advantage of using final in these three scenarios. Okay, so let me go to PPT. So what could be the possible interview questions here? What is final keyword in Java? How many ways we can use final keyword in Java? So that's all in this video. Thank you. Hi, in this video, we will talk about encapsulation in Java. So what do you mean by encapsulation? So encapsulation refers to binding of fields and methods inside a single class. So encapsulation means you binding your variables and methods inside a class. Okay, so we'll see more. It prevents outer classes from accessing and changing fields and methods of a class. So with the help of encapsulation, you can restrict your class, or inside the class, you restrict accessing your methods and variables, all these things. So how you can achieve that? You can create fully encapsulated class in Java by making all the data members of the class as private. So with the help of a private keyword, you can achieve this encapsulation. Okay. So this is one of the access modifiers, right? So least access. So when you provide private, within that class only, you can access the information. But if you want to access outside of that class, with the help of private, you cannot access. So then we can use setter and getter methods to set and get data in it. Okay. So then how you can access, if I want to access something which is private. Okay. At that time, with the help of setter and getter methods, we can access those information. Okay. So this is called encapsulation. But what is the advantage when you use encapsulation? So advantage of encapsulation, by providing only a setter and getter method, you can make the class read only or write only. So in other words, you can skip the getter or setter method. So you can restrict not to access anything from that class. But if you want to access, you can use setter and getter methods. It provides you the control over the data. If you want to set the value of a variable, which should be greater than 100 only, you can write the logic inside the setter method. You can write the logic not to store the negative numbers in the setter methods. Means, so you have one variable. So if you want to access that, it should be a public or more than that private. Okay. So if you make it not private, so anybody can access that variable, and anybody can set any value to that variable. So that time you cannot have control over that variable, but somehow you want to control that access. So with the help of this encapsulation, with the help of the setters and getters, you can have control over that variables. With the help of a program, we can understand everything in detail. So it is a way to achieve data hiding in Java, because other class will not able to access the data through the private data members. So this concept is also called data hiding. So you are not providing any information to outside. So you are hiding the data inside that class. Okay. So this is the advantage of encapsulation. So by taking one example, we'll understand all the points which we discussed. Okay. So let's go to Visual Studio Code. So here I created one of the classes called encapsulation demo, and have written main method. Okay. So, and we are talking about the two classes, right? Accessing some other class. So we'll create some other class. I'll name it as employee. So inside the employee, let's assume I have an int employee ID. Okay, that's it. So now, with the help of employee class object, employee E is equals to new employee, and then E dot employee ID is equals to 100. Then system dot out dot println E dot employee ID. I'm printing it. I'm assigning one value to this employee ID, which is there in the employee class, and I'm printing the same thing. Okay. So we'll try to execute this, and we'll see whether we were able to access this employee ID from this class, and we were able to assign some value to that, and we were able to print that. Okay, let me go to the command prompt, Java encapsulation demo.java. You see that I'm able to print 100. Okay, so I'll give another value, -50. I'm giving some negative value. So let me try to execute again. You see that I'm getting -50. Okay, I'll give some 15, 20, something like that, one random number. Execute. I'm getting. So from other class, I'm able to manipulate this employee ID. Whatever value I want, I'm giving. But in real time, I don't want to provide minus values. Okay, I can access that value, but there is some restriction. I can set only these type of values. Okay, there is some rule. So how you can achieve that? How you can control in such a way? So if you make it private, then okay, you made it private. Now you try to execute now, then you'll get an error that you see employee ID has private access in employee. Okay, this is compilation failed. So how can I access? If I remove this one, I do not have control over that variable. If I provide that, I cannot even access that. Okay, but I don't want these two scenarios. I don't want to give full control and I don't want to give full restriction on that. Okay, that time make it private, and with the help of setter and getter methods, then you can achieve this. Okay, so first public void set employee ID. So when you try to use setter and getter methods, whatever the variable, for that you will put set and you make it this E as capital, means normally we'll start with small e, right? So that will become, but this is not a rule. So in general, we'll say setter and getter. You can give whatever name, but you'll get confused. If you revisit your program, you'll get confused that what purpose you have written this one. So if you put maintain the consistency that get and set, then you'll understand for this variable, you are able to set something. If you put get for this variable, you are getting that value. So public void get employee ID. Okay. So this is how, with the help of these two methods, set and get, these are called setter and getter. So with the help of these methods, I can manipulate this information and I can set, I can get the values. Okay. So we'll see. So what we'll do, I'll provide the same employee ID. So while providing, I'll set this value to this value. So how you can do that? This dot employee ID is equals to employee ID. Whatever I set this information, I'm assigning to this employee ID. All right. So we already discussed what is this in one of our previous videos. So access current class object means information. So then I can get this information. I have set this information. So then I can get this information. For that, you need to use return employee ID. But when you're returning something, what is this integer value? So the return type should be integer. So I need to change it to integer. So this way you can access private variables or private members from other class, right? So now we'll see how we can do that. Let me comment out this. And I need this line again. So now what I'll do, first I'll set the value. How we did this one? This way we need to do with the help of method. So E dot set employee ID. I'll give same way 100, just an example. And once you call this method, so employee ID, what we are passing 100. This 100 is I am assigning to this employee ID, and I am returning the same employee ID from the get employee ID. So then what is this? With the help of this get method, I can access whatever I set. Okay. We need to set with the set method. We need to get this from get method. So if I try to execute this, you see that 100 I'm printing. So just make it -50. That -50. And the same way 15, 20, whatever we have given in the previous example, same thing. 15, 20. So then what is the use of this? We did the same thing without setter and getter by making this not private. We see everything. But what is the use when you try to use the setter and getter? Right, that time. So if you have a variable, you cannot put some conditions on that. But if it is a method, you can have some conditions, if else condition, something like that. So what I'll do then, I'll put a condition here. If employee ID is greater than 0, then only you set this employee ID to that. Okay. When the employee ID is greater than 0, then only assign that employee ID to this employee ID and provide the same information. Okay. So now I'm able to put some condition on this employee ID. Right. Previously, that is not possible. But with the help of methods, I can write this if else conditions. I can put some condition on this. That is the flexibility I get when I use private and use the setter and getter public methods. Okay. So if I try to execute this, nothing changed 15, 20. But if I put minus value, -50, previously when you do not have this condition, I can assign this value, I can get this value. But you see now that it is giving me 0 as the default value is 0. Integer default value is 0. But I'm not getting -50. Okay. If you make it just 1, and if you try to execute 1 is greater than 0, then obviously you'll get 1. Right. Other than positive numbers, you will get 0. The reason is default value of integer is 0. Right. That is how I am restricting, putting some conditions on that. Right. So in the real time, it will be helpful. According to your requirement, you will give the access to this employee ID outside the class, even though if it is private. If you do not have setter and getter, you will not have control on this. You can manipulate how you want. Okay, that is the advantage when you use encapsulation. Okay. So what could be the possible interview questions from this? So what is encapsulation in Java? What is data hiding in Java? How to achieve encapsulation in Java? Okay, these are the possible interview questions from this topic. Okay, that's all in this video. Thank you. Hi, in this video, we will discuss about exception handling in Java. So what do you mean by exception handling in Java? We will see. So before that, what exactly an exception is? Okay, an exception is an unwanted or unexpected event which occurs during the execution of a program, that is at runtime, that disrupts the normal flow of the program's instructions. So you have written one program, and obviously you will expect that program will execute smoothly, successfully. But in any one of the lines or statements, it means there might be an unexpected event or unwanted event will happen, and that disrupts your normal flow of the execution, means it will not successfully execute your program. So that is called an exception. Okay, unwanted or unexpected event, okay, in your execution. So that is called exception. So exception examples in day-to-day life. So in our day-to-day life also, we might see some of the things. So when you start your day, you feel that everything will goes fine. right? But sometimes what will happen, so you need to pay something to somebody, but you insufficient balance in your bank account. Okay, you'll not have sufficient money. So whatever you expect in this day might not be that smooth. So you're traveling to somewhere and suddenly your car tire got punctured. So because of that, you cannot travel to the destination smoothly. So power off while watching the World Cup match. So you're watching World Cup match, but suddenly power off. So you'll not expect that. So because of that, what you are expecting, you want to see the match, but suddenly power gone. So you cannot continue how you expected. So these are all the exceptions in your day-to-day life. So when you're coming to the programming, so if you talk about the Java programming, what are the exceptions will happen? So opening an unavailable file. So there is a file, but that is not available at present, but you try to open that file. You feel that there is a file, but unexpectedly there is not, that file is not available, but you're trying to open the file using your code. And the same way, reading data from the unavailable file and writing data to an unavailable file. So loss of network connection. You are executing something, but there is a loss of network. So whatever you expected will happen how you expected. So invalid user input. So these are all very common, no exceptions will happen in your programming. Okay. So now what is exception handling? Right, till now we have seen what is exception. Exception is that will disrupt your normal flow. But what is exception handling? The exception handling in Java is one of the mechanisms to handle the runtime errors so that the normal flow of the application can be maintained. So obviously something is not going properly. You want to set that. So you want to maintain that properly. So with the help of exception handling, with that mechanism, you will handle your runtime errors. And because of that, your application flow will be normal. So normal flow of the application can be maintained. How you do that we will discuss. Okay. But when you go back to the previous slide here, so I'm saying insufficient balance in bank account, right? So that time what you will do, you might get some money from one of your friends and you can arrange that time. Okay. So that is you're maintaining that exception. You're handling that exception with this resolution. Okay. Car tire got punctured. You might have an extra tire, right? With the help of that extra tire, you will manage that time. So power off while watching the World Cup. You might watch in your mobile, otherwise you will have a power backup. So with the help of that, you can manage that. So this is how you can handle your exceptions. In the same way, in the programming also, you can handle this type of exceptions. So opening an unavailable file. So you're trying to read one file. So if that file is not available, read from here. Something like that you can manage. Okay. So loss of network, you can manage some backup and invalid user input. So if you give some invalid user input, so if it is not proper, if you're not getting the proper input, so instead of that, use this predefined input, something like that. Okay. So this is how you can manage your, means you can handle your exceptions. So what is the advantage when you go for exception handling, right? So exception handling ensures that the flow of the program is maintained when an exception occurs. So that is what we are seeing, right? Some exception happens, but with the help of exception handling, how you expecting to execute your program, how smoothly you want to execute, so that you can achieve. By this, we can identify the types of errors. So you'll come to know that what kind of exceptions or errors will happen in your come in your program. By this, we can write the error handling code separately from the normal code. So to handle this error code, we'll use some separate blocks, all these things that we will see in our next videos, but that code is separated from the normal code. Providing meaningful message to the user. So sometimes what happens, something is happen. So system will give some output to the user, but that may not be understood by the user. So with the help of exception handling, a meaningful message can be passed to the user. So with the help of that message, you can understand, okay, what happened, why, because this is happening, this exception is happening, that will come to know. Okay, these are all advantages when you talk about exception handling. So what could be the possible interview? So what is an exception? So we already discussed exception is unwanted or unexpected event occurred in your program flow. So what is exception handling in Java? So how you make it, your program execute smooth. So that is called exception handling. So examples of exceptions. So we have seen that, we are trying to read the unavailable file, giving wrong user input, invalid input, something like that. So advantage of exception handling. So we just saw that, right? So you can explain all these things as part of exception handling. Okay. So that's all in this video. Thank you. Hi, in this video, we will see default exception handling. So what do you mean by exception? We already discussed something abnormal happened in your program execution, unwanted thing. So it will interrupt your smooth execution. So what do you mean by exception handling? So to avoid that, we'll try to handle that with the help of some extra code. Okay. So, but if you do not have that code, then what happens? What is default exception handling? Okay. So with the help of one program, we'll try to understand this one. So here I have created one class called default exception handling. So inside this, I have a main method public static void main. Inside that, I am calling another method called method one. Okay. So when I come to the method one, there is another method I'm calling method two. So when you jump into the method two, so I have a string and I'm trying to print the length of that string. Okay. But my string is null. Okay. My string is null. There is no string. So then what happens in this scenario? So, and I'm not handling that when something happens, if null is there, I need to do something like this. That is handling exception handling code, but I do not have any exception handling code. So first we'll try to execute this code. And we'll see what will happen if you try to execute this. So let me copy this class in. So I'll just try to execute. You see that I'm getting an exception. Exception in thread main java.lang.null pointer exception. So I'm getting what kind of exception? Null pointer exception. Where I'm getting, so at default exception handling, this is my class name dot in the method 2. Okay. So that method 2 is calling from where? From method 1. That method 1 is calling from where? From main method. So what happens when this kind of exception happens? So main method who will call? So JVM call your main method. Right? JVM look for any handling code. Where I exactly got this issue? In the method 2. So let me annotate this. So where I got an error, this exception, so I got in this method 2. So JVM will search for any exception handling code is there or not. Exception handling code for this. So, but I do not have anything here for this code. So normally what it will do then, so which method is calling this method? So method 1 is calling. So here it will search any exception handling code is there for this method 1. So here also I do not have any exception handling code. So this method 1 is called by which method? So main method, right? So here also I do not have any exception handling code. So this one who is calling? So JVM is calling, right? So now what it has to do? So it has to do something, means it has to give some meaningful information to the user, right? What exactly happened? If it simply sits, so what you will understand as a user, as a programmer? So how you, when you executing this, right? When you're executing this, you got some issue here. Okay, you got some issue here that is called null pointer exception. So this, from where it is coming? Who is giving this information to you when you execute, right? So then, so JVM has to take care of these things. So the moment when it happens, what it will do, where it exception happens, so there it will create one exception object. Okay, it will create, exception object. So who is responsible to create this exception object? Where exactly this happens means method 2 is responsible for creating an exception object. So once it create an exception object, so it will hold that what is the exception name, and it will have the description and stack trace. Okay, stack trace means from where it is, all calling from method main to method 1, method 1 to method 2, something like that. So it has to give this information. Okay, so normally how the execution will be, so the moment the execution starts, so it will create one thread. Okay, JVM will create one thread. So we already discussed in the starting, when you talk about the Java programming, Java is a multi-threaded programming language. So because of that, it will create one thread. So what it will execute first, it will create a main method. So it is calling main method. So main method is calling what? Method 1. So it will create an entry for method 1. So then it will create method 2. Okay, if it is executed smoothly, so it will terminate from here. But what happened here? Method 2 got an issue. So here what it will do, it will terminate, because of this exception, it will terminate your program abruptly. There is no smooth execution. Right. So then here we are discussing JVM, right? So this JVM, what it will do, there is one mechanism called default exception handler. So default exception handler will be there. So it will give this task to this one JVM. So what this default exception handler will do, so it will give the information what you are seeing. It will capture that information from here and it will give the meaningful information. Okay, so how it will be exception in thread main, and what is that exception? Null pointer exception at which each, from method 2, from method 1, from where it is calling, everything it will provide that information. If you want to see that, you see that exception in thread main java.lang null pointer exception, and where it is coming from method 2, from method 2 to method 1, from method 1 to main method. So this complete information it will give. That is the duty of default exception handler. Okay, so now what I will do, so I'll change a little bit my program. Okay, so instead of raising this here, so I'll raise here. Okay, and what I will do in the method 2, I'll write a simple message learning about default exception handling. Okay, something like that. So let me put this one in the top. Okay, so now what happens when you try to execute? So it will call method 1. The moment when it comes method 1, it will call method 2. It will jump into the method 2. So it will print this one. After it is printing, it will come back. So after this, you have something else. So when you call this, so you get the exception here. So we'll try to execute this and we'll see. You see that? Now it printed learning about default exception handling, and you'll get the same exception, but where it is coming in the method 1. Method 1 is calling from main. So you'll have only these 2 lines instead of 3 lines. Right. The moment when it comes, so from there only you'll get this kind of information. Right. Now what is the who is responsible to create this exception object? So method 1 is responsible to create the exception object, and there is no handling code. So it will search for main method in the main method. Here also nothing is there. Then JVM will take care of this. It will delegate this thing to default exception handler. That will capture the information, that will print this information for the user. Right. Then you'll come to know that what exactly happened. Okay, I'm getting null pointer exception. Where it is I'm getting? So in the 10th line. So in the 4th line it called. Okay, in the 4th line it called. So in the 10th line I'm getting this one. So what's wrong with the 10th line? So unfortunately, so I unknowingly or knowingly I have given string as null. I need to give some string, then only it will execute. It will print the length, otherwise you will get the exception. This way you will understand. Okay, so if you do not have the exception handling code, then JVM will do this mechanism with the help of default exception handler. Okay, so that is what default exception handling in Java. So what could be the possible interview questions from this? What is an exception? What is default exception handling in Java? Examples of exceptions, advantages of exception handling. So can you tell me, can you explain default exception handling with the help of one program, something like that? Okay, so that's all in this video. Thank you. Hi, in this video, we will see exception versus error. So when you try to execute any program, there are two possibilities that you might get exception or sometimes you might get error. So we should know what is exception, what is error, what is the difference between these two. So that we are going to discuss in this video. Okay. So exception. Exceptions are the exceptional conditions that occur in a runtime environment. Most of the times exceptions are caused due to the code of our program. Okay, so exceptions are exceptional conditions that occur in a runtime environment. That already we saw that what is exception. So it might disrupt your program. So there is no smooth execution. Something happened in between. But this will happen most of the times due to our code. So whatever we have written the code, because of that, you will get an exception. Okay, but what is error? Errors are critical conditions that occur due to the lack of system resources, and it cannot be handled by the code of the program. So that might happen because of our code, but error is not happening with the programmer code. This is happening because of lack of system resources. Okay, so both are different. Okay, we'll go into the deep and we'll understand what exactly it is. So at the high level, exceptions are exceptional conditions that occur in runtime environment. Most of the times, exceptions occurs with the due to what? Our program. But errors will not occur due to our program. So these are due to lack of our system resources. Okay. So we'll try to see the differences between these two. Then we'll understand what exactly this is. So exception. So exception is caused due to the programmer code, our code. Okay. But coming to error, an error is caused due to lack of system resources. You see that lack of system resources. Exception is recoverable. Very important point. So an exception is recoverable. An error is not recoverable. Right. So that is what we are talking about, exception handling. So we can handle the exception. So because of that, we are discussing about exception handling. Means we can recover that scenario. Exception is recoverable, but an error is not recoverable. So we cannot do error handling. We can do only exception handling. Okay. So exceptions are handled by few keywords like try, catch, throw. So these are few keywords. When you talk about exception, we need to learn all these things that we will see in our upcoming videos. But here, so with the help of try, catch, throw keywords, we can handle exceptions. So cannot handle the error with the program code. So this try, catch, throw, where you will write in your code only. So with the help of this, you cannot handle errors. When an exception is detected, it is thrown and caught by the throw and catch keywords correspondingly. Okay, so something is thrown, means your exception is thrown, that is caught by your catch and throw. When an error is detected, then the program will terminate it abnormally. So with the help of try, catch, throw, we cannot do anything here. Here it will terminate your program. Okay, so exceptions are classified as checked, and unchecked type exceptions. This is also very important topic. We will discuss about what is checked exception, what is unchecked exceptions, what is the difference between checked and unchecked exceptions, everything in our upcoming videos. So errors are classified as unchecked type. These are not unchecked exceptions, but unchecked type. So this is also, sorry, this one and this one comes under same category, unchecked type. Okay. So let me clear this. So we have few more. So when you talk about exception, so exceptions can be checked or unchecked. So they may or may not be detected by the compiler. Right, depends upon the compiler. So whether it is checked or unchecked, that we'll discuss. But if it is checked, exceptions can be checked or unchecked. So they may or may not be detected by the compiler. So error occurs at runtime and are not detected by the compiler. Right. Here may or may not, but here 100% at the runtime only. So exceptions are defined in java.lang.exception package. And the error is same java.lang.error. Okay. So few of the examples for exception is no such method exception, class not found exception, null pointer exception that we saw in our previous exam in the default exception handling. So we got null pointer exception. So file not found exception, something like these are all few exception examples. Coming to the error, out of memory, stack overflow error. So these are few examples for the errors. Okay. So this is the difference. What is exception, what is error, and what is the difference between these two. Okay. So we should have some information about all these things going forward while we discuss about the next topics. Okay. So here, what could be the possible interview questions from this? So people will ask what is an exception, what is an error. So difference between exception and error. So exception can be recovered, but error cannot be recovered, right? That is important point. So can you name few exceptions? Null pointer exception, file not found exception. These are all some exceptions. Can you name few errors? So stack overflow error, something like that you can explain. Okay. So that's all in this video. Thank you. Hi, in this video, we will discuss about exception hierarchy. Okay, what do you mean by exception hierarchy? We'll see with the help of one diagram. Okay, so this is what a diagram to represent this exception hierarchy. So when you talk about everything is in class in Java, right? Everything is class in Java. So what is the super class for these exceptions? So that is called throwable. Throwable, the super class in exception. Okay, in entire Java, in Java, object is the super class. Okay, object is the super class, but here throwable is super class in exception. So throwable has two child classes. Those are error and exception. Okay, two classes. For this also, it is categorized into so many categories. Means it categorizes so many things. Like so, if you talk about runtime exception is one of the child of this exception. So IO exception, interrupted exception, remote exception, SQL exception, etc. There are so many exceptions are there. We cannot bring all these things to this PPT and we cannot explain all these things. But so with the help of few exceptions, we'll understand what exactly the hierarchy is. So first it is throwable. This is the super class in exception. So for this you have two child classes called, one is exception, another one is error. So this exception is also categorized as runtime exception, IO exception, interrupted exception, remote exception, SQL exception, etc. So when you deep drill into this one, okay, when you dig into this one, so in the runtime exception you have another child classes. So few of them are arithmetic exception, null pointer exception, class cost exception, illegal argument exception. So these are all comes under what? Runtime exception. And when you talk about IO exception, so file not found exception, socket exception, unknown host exception, end of file exception. These are all comes under IO exception. And when you talk about remote exception, connect exception, access exception, server exception. So these are all comes under remote exception. When you talk about SQL exception, so sync provider exception, serial exception, so SQL client info exception. So these are all comes under SQL exception. So these are all comes under exception class. Okay, so there are another exception. So many exceptions are under that. You have subclasses also. Okay, so but when you're coming to the error, so we already saw what is the difference between exception and error, right, in our previous video. So when you're coming to the error, you have multiple classes: linkage error, assertion error, virtual machine error, thread death error. So where if you go into the deeper in the linkage error, you have bootstrap method error, class format error, exception initialized error. When you talk about the virtual machine error, so internal error, out of memory error, stack overflow error. So these are comes under virtual machine error. These are comes under linkage error. Okay, so here also we have few more, but to describe all these things, I have taken few, and I have taken this diagram to explain in detail. Okay, so thrower is the superclass in exceptions. So this has two child classes called exception and error. Exception has so many child classes. Error also has so many child classes. For those child classes also we have few more child classes. Okay, this is the hierarchy. So if somebody asks about this one, you can say with this, with the help of this, diagram, you can explain this much is enough. You cannot write each and every exception. This is enough. Okay. So what could be the possible inter-equation from this? Okay, so what is an exception? What is an error? Difference between these two? Can you name few exceptions? Can you name few errors? And you can you tell me what is that? This exception hierarchy. So throwable is the parent class. For that you have two child classes called error and exception. For the exception you have multiple exceptions. For error also you have multiple error classes. Okay, so that's all in this video. Thank you. Hi, in this video, we'll talk about checked versus unchecked exceptions. Okay, so till now we discussed about exception. Inside that we have we discussed about exception and error. So all these things, right? So but suddenly we are talking about checked versus unchecked exceptions. So exceptions are categorized into checked and unchecked, that we saw in one of our previous slides or videos. When we're discussing about exception versus error, right, checked and unchecked type. So that we are going to discuss in detail here. So when you move forward, first we need to remember one thing: checked and unchecked both exceptions will occur at runtime. Okay, checked and unchecked both exceptions will occur at runtime. That information we need to remember. Then we'll talk about the checked type. So the checked exceptions are those exceptions which are checked by the compiler for the smooth execution of the program. Okay, the compiler checks whether the program can handle the checked exception or not. If the code is unable to handle the exception, there occurs a compilation error. Right, there occurs a compilation error. All the subclasses of class exception except the runtime exception class are the checked exceptions. Okay, so what exactly we are discussing here? So the checked exceptions will occur at compile time. It means compiler will check and it will throw. So what exactly happening at the compile time only, if there is no handling code. Okay, so what exceptions comes under checked exceptions? Except the runtime exceptions, remaining all comes under checked exceptions. Okay, so this is called checked type. Checked exceptions are those exceptions which are checked by the compiler for the smooth execution of the program. The compiler checks whether the program can handle the checked exception or not. If the handling code is not there, then it will throw a compilation error. So except runtime exception, all other exception comes under checked type. Okay. So unchecked type. So unchecked exceptions are those exceptions which are not checked by the compiler. Okay. The compiler compiles the program successfully even if the exceptions are not handled by the code. What kind of exceptions? Unchecked exceptions. The class error and its child classes, the class runtime and its subclasses are the unchecked exceptions. So in our previous slide, what we said, except runtime exception. So that comes under unchecked. Apart from this runtime, error category also comes under unchecked type. Okay, these both comes under unchecked type. These are not checked by the compiler. If you have that issue also, it will compile without any issues. Right. So now you take a diagrammatic way of this representation. So if you see here, I have created throwable, right? This is the superclass for exception. So inside this you have exception and error. So in the exception you have multiple exceptions like SQL, IO, interrupted, etc. But I separated this runtime exception from this category because these are all checked type. But coming to the runtime exception, error, these two comes under unchecked type. Right? Even though this is an exception, but it comes under unchecked type. Error by default unchecked type. Okay. If somebody asks what is checked exception, except runtime exception and its subclasses, remaining all comes under what? Checked exceptions. What is unchecked type or unchecked exceptions? So runtime exceptions and its child classes all comes under unchecked exception, and error is unchecked type. Okay, this is what we need to explain when somebody asks about checked and unchecked exceptions. Okay, now we'll see the difference between these two. Okay, so compiler checks the checked exceptions. Okay, compiler will check the checked exception, but coming to the unchecked exception, compiler does not check. Okay, so except runtime exception and its child classes, comma, error and its child classes, remaining all are checked exceptions. And the reverse of this, runtime exception and its child classes, error and its child classes are unchecked type. There is a typo. So this is unchecked type. Okay, let me correct this. So you can see now, right? And child class are unchecked type. These are checked type. If programmer does not handle the checked exception, then the compiler objects. It will tell you, it objects you that there is an issue. But coming to this one, the compiler does not object. It will compile, no problem. If you have unchecked exception or unchecked type also. Program does not compile if there is an unhandled checked exception. So program compiles successfully even there is unhandled unchecked exception. There is no need to handle here, but here you need to handle, otherwise it will throw a compilation issue. So examples from the checked exception are SQL exception, IO exception. Here arithmetic exception, assertion, error. Okay, these are difference between checked and unchecked exceptions. Okay. So before going to that, we'll see with the help of one example, we'll see one checked exception and unchecked exception. So let me go to Visual Studio Code. So here I created one class called checked exception example. So inside this, I have written one program. This we already saw very long back as part of scanner class. So the same code I copy pasted here. What I'm doing here, I'm trying to read the data from one of the text file called data.txt that is there in this location. Okay, that is there in this location. So I'm telling that this is the path of my file. From here you read, and if there is how many lines are there, you just keep print those lines. That is what the intention of this. So if I go back to command prompt, if I try to execute this, okay, so Java C, I'm just compiling now, okay, dot Java. Java C checked exception example.java. So obviously you will get an issue. So when you go up, now what it is saying? It is saying, so file, I don't know what exactly this file is. So this file, from where it has to come? It has to come from these packages, right? Java.util and java.io. So scanner comes from util and file comes from the java.io. That is what it is saying. So that I imported. Now we try to execute this again. Now you see that unreported exception, file not found exception must be caught or declared to be thrown. Okay. So it is saying file not found exception, right? But this file is there. You see that this location I have that file. Even though I have file, it is objecting, right? There is no issue, nothing. File is there. I'm writing the entire code is proper code, no error code. This is, even though it is objecting, right? So now you need to understand one point we said, right? That is both exceptions are, checked and unchecked will, all comes at runtime only. So why? Because even though if the file is there, it is giving me file not found exception. So if the file is there, it should not write normally. That is what, theoretically, if you talk about. But even though Java, what it is doing, even though file is there, it is saying file not found exception. Why? So intention of this is, when you deal with these kind of means, when you deal with any file, there might be a chance that you might miss that file in that location. It got deleted because of so many reasons. We don't know, right? That is what the intention. So this exception you will get if the file is there or if the file is not there. In both the scenarios, you will get the same, like exception. But the intention is, there might be a chance. There might be a chance that file may not available. So that time you will face some issue. So take care of these things. That is what it is warning us. So that is called checked exception. It checked that, okay, you are dealing with some files. If you are dealing with some files means there might be a chance that file may not be available in the runtime. If that is not available, your program will not execute smoothly. So I am telling you, take care of this. That is what checked exception. Okay. So when you talk about unchecked exception, okay. So a simple program, what I'm doing, system.out.println 1/0. I have given 1/0. So obviously 1/0 means it's an exception kind of, right? So what you do, you try to execute this. You try to compile this now. First Java C. You see that compiled successfully. Even though in normal way 1/0 means it will be infinity, right? We cannot count that. We cannot get the output of that. But theoretically means syntactically, if you see that syntax, it's a 2/3, 1/3, 1/0, 2/0. So it doesn't see any differences there. You are dividing. You are using division. That's it. Okay. So that is the reason it will not give any exception when you compile. Okay. But when you run this one, now it will throw an exception, that exception in thread main java.lang.arithmetic exception divided by 0. So divided by 0 is an exception, right? In mathematics. So that is because of that it is saying arithmetic exception divided by 0. Right, where it is coming? In this class, unchecked example.main method, in the main method, in the line number 3. Right, so this is not checked by the compiler. So because of that, it is treated as unchecked exception. Okay, this is one of the examples. How you will handle all these things, that we will discuss in our upcoming videos. But here I'm just showing you how checked exception, unchecked exceptions will look like, and when you execute, how the behavior, output will be. Okay, so that's all about checked and unchecked exceptions in Java. So what could be the possible interview questions from here? So what is checked exception? What is unchecked exception? Difference between these two. Can you name few checked exceptions? Can you name few unchecked exceptions? In which category error will come? Unchecked type, right? So these type of questions you may face. Okay, so that's all in this video. Thank you. Hi, in this video, we'll talk about fully checked and partially checked exceptions. So in one of our previous videos, we have discussed about checked exception and unchecked exception or unchecked type. So in this video, we have inside the checked exceptions, we have fully checked versus partially checked exception. So we'll see what is fully checked and what is partially checked. So when you talk about fully checked exception, a checked exception is said to be fully checked exception if and only if the exception class and all its child classes also checked. Okay, so what do you mean by that? When you talk about fully checked exception, so a class and all its child classes. So class and its child classes. Okay, so all are should be checked. Okay, then those are called fully checked exceptions. So if you talk about few of the examples, so IO exception, interrupted exception, SQL exceptions, these are few fully checked exceptions. Okay, so checked exception means the class and all its child classes also should be checked, then only those are called fully checked exceptions. Okay, so then what do you mean by partially checked exception? So let me clear this. So when you talk about partially checked exception, so a checked exception is said to be partially checked exception if and only if some of its child classes are unchecked. So the class, parent class is checked. But if you have some childs for this, few may be checked, few unchecked. Okay, so all child classes are not checked. So few are unchecked, few are checked. Then those are called partially checked exceptions. Few of the examples is throwable and exception. Okay, so this is the difference between fully checked versus partially checked exceptions. So if you look into this diagram again, which we already saw in the exception hierarchy. So the main class is parent or superclass for exception is what? Throwable. Okay, so throwable has error and exception. So inside the exception, runtime is unchecked. Okay, so if you talk about something like this, throwable has exception and error. So error is unchecked type, right? Error is unchecked type. So throwable has exception and error. So obviously it will become partially checked. Okay, this is partially checked. So when you talk about error, anyway it is unchecked exception, no need to talk about this. But when you come to the exception, you have so many child classes. In those, runtime exception is unchecked. So remaining all are checked. So as per the definition, if a class has unchecked, then that will become partially checked exception. Okay, so these two, throwable and exception. So these two are partially checked exceptions. So apart from that, do you see any other partially checked exception? So anyhow, this way, no chance. These are all unchecked. You need to talk about this right side. Inside this, so except this, all are checked exceptions, right? So if you talk about this one, this is checked and these are also checked. So it is fully checked exception. This is also fully checked. This is also fully checked. So this is also fully checked. Anyhow, runtime is already unchecked, right? No need to talk about its child classes even. So in this way, by looking into all these things, we have only two classes which are partially checked. That is throwable and exception. So there are only two partially checked exceptions are available in Java. Those are throwable and exception. Okay, so this is all about fully checked and partially checked exceptions. So when you talk about possible interview questions in this, so what is fully checked exception? What is partially checked? What is the difference between these two? Can you name few fully checked exceptions? Can you name few partially checked exceptions? So coming to the partially checked, you have only two. Those are throwable and exception. Okay. So that's all in this video. Thank you. Hi, in this video, we will talk about customized exception in Java. So what do you mean by customized exception? We will talk about all these things in this video. But previously, one of our previous videos, we discussed about default exception handling. So if you do not have any handling code for your exceptional code, that time JVM will take care of the exception and it will delegate the task to default exception handler, and that will print the information to the user. But I want to handle my exception. I want to print or I want to handle that exception in my own way. So for that, we'll use customized exception in Java. So we'll handle the exceptions using customized exceptions in Java. To achieve this, we'll use try catch blocks. So try and catch both are predefined keywords in Java to handle exceptions. Okay. So the try catch block in Java is used to handle exceptions and prevents the abnormal termination of the program. So if you get an exception, you will get abnormal termination. To avoid that abnormal termination, we will use try catch block and we'll handle that exceptions. Okay. With the help of one example, we'll see. But how the try catch block looks like. So you see that try and you have this, how you write the curly braces for the method, and the same, this is try block. In the similar way, we have seen static block in one of our previous videos. The same way, try block and catch. In this, it will accept exception class object. So in the try, you will write risky code or exceptional code. So wherever you feel that this is exceptional code, in this line or in this code, you will get some exception. So that kind of code you will put inside the try block. Okay. In the catch block, handling code or recovery code. So exception handling is recovery your the exceptions, right, in your smooth execution, right? If you want to go for smooth execution, you need to handle those exceptions. So in the catch, you will have handling code or recovery code. If something happens inside the try, so directly it will jump into the catch and it will execute this alternate recovery code. Okay. So with the help of try catch block, we'll do all these things. And this is the syntax. Okay. With the help of one example, we'll see. So let me go to Visual Studio Code. So here I created one of the classes called customized exception example. So I have written one main method. So inside this, let me write some system.out.println statements. So first statement, and let me take two more. Okay. So here in the second statement, what I'll do, I'll give some code like 5/0, and this is second statement or third statement, whatever it is. Okay. I have three statements, but here I have risky code. Right. Here you will get arithmetic exception. Right, that we know. So I'm not handling this. So let me execute and see how the default exception handler will execute and what it will give us. You see that? So exception in thread main java.lang.arithmetic exception by slash means divided by 0, right, in this line. So but I don't want to do something like this. I want smooth execution. I don't want to see these kind of errors or no what exceptions. So that time, so this is the risky code, right? So I'll put this risky code inside the try block. So let me put in the try. So then you should have a catch block, right? So in the catch block, you need to mention what exception? Arithmetic exception. And that object. So inside this, whatever you want, you can do. Okay. System.out.println. So if 5 by 0 is an exceptional code, you can give some alternate code. You execute this something like this. Okay. Otherwise, you can give some meaningful name information to the user, right? So found arithmetic exception, please take care of this. Okay, just an example. So now let me comment this. So now you will see now, you try to execute the same thing. You see that here after the first statement, you got exception. So it ignored the rest of the program. But here is a first statement. So you found some risky code here. So it jumped into this catch block. So because of that 10 by 2, I got 5. So it is smooth execution. We already caught that exception. So it came out of that catch and it executed this statement also after this risky code, right? So that's how you can manage your exceptions. So let me execute once again. You see that first statement, found arithmetic exception, please take care of this, and then third statement. All right. So whenever you see some risky code or exceptional code that you should put in try block and something goes wrong here, it will jump into the respective catch block. So it will execute whatever you mention inside this catch block. Right, that's how you will handle and you will get the smooth execution. So in the first statement, without try catch, it terminated the program. It executed only this third line. So after that, it did not execute it. But now, with the help of try catch, so I'm able to print this 11th line also, because I handled that. If something goes wrong, you execute this alternate code. So according to your risky code, you need to put your alternate code. But here, just an example. Okay. So that's how you will handle your exceptions. That is called customized exception. So default exception handler is not handling your exceptions. You are handling. So because of that, this is customized exception. Okay. So what could be the possible interview questions from here? So what is customized exceptions? What is try block and what it contains? So try block is a block where it will contain risky code. So what is called catch block and what it contains? So catch is a block and it will have that handle code or recovery code. Okay. So that's all in this video. Thank you. Hi, in this video, we will see try catch control flow. So inside the try catch, how the control flow will be if you find any risky code or exceptional code. So we'll take one example and we'll try to see some of the cases in that. Okay, let me go to Visual Studio Code. So here I have written one program called class called try catch control flow example. So inside this I have a main method. Inside the main method I have written some system.out.println statements, and here I have some cases. Okay, So this is the first statement I'm printing 1. So you have a try inside this, you have 3 more statements, 2, 3, 4. And after that in the catch, I have 5. And after that, I have 6 to print. So in this entire program, so no exceptions in the program. So I don't see any exception, just the println statements, right? I don't see any risky code, even though it is in try catch block. So if you do not have any risky code, so what could be the output from this? Okay, so what could be the output of this one, right? So with our knowledge till now what we discussed, so the control comes here, so it will print 1, right? So then it will go to the try block. So in the try block, it will come here, it will print 2, 3, 4, no risky code. So if you do not have any risky code, it will never go to the catch block. Okay, when catch will execute, if you find something exceptional code in try block, otherwise it will never visit catch block. So because of that, it will not go inside this and it will not print 5. So then it will come out of that and it will print 6. Okay, this is the flow. If you talk about the here, we'll see the output. Okay, so it will print 1, comma 2, comma 3, comma 4, comma 6. And how the execution is, this is normal termination, but smooth termination. Abnormal, not abnormal termination. Okay, smooth termination. Okay, and okay, so this is 1, 2, 4, sorry, 3, 4, right? So we'll try to execute and see the same 1, 2, 3, 4, 6. It has to print. So let me clear this. So it has to print 1, 2, 3, 4, 6. 1, 2, 3, 4, 6, and smooth termination. I did not see any issues. Okay, this is case 1. So exception at statement 2 and corresponding handling code available. The handling code is available. Okay, so now here I found some risky code. I'll say 5 by 0. Okay, so when you talk about the 5 by 0 here, so now we'll see what it will, the execution flow. Okay, so first it will come to the statement 1, so it will print no problem. So inside the try here also no problem, but when it comes to this line, 6th line, so we have arithmetic exception here. So the moment it finds, then it will jump into the catch block. It will find, is there any respective catch block? So I found arithmetic exception. Okay, so then it will jump into this one. So it will print 5. So handling code it will execute. Then come out of that 6. So what could be the output? 1, 2, 5, 6, and smooth termination. Okay, smooth termination. So 1, 2, 5, 6. Okay, let me clear this. And so what is this output here? 1, 2, 5, 6, comma, smooth termination. And we need to remember one thing. So we have this line 4. What about this one? We are handling here, that is fine. But what about this? So the moment when the control, once a control comes to the catch block, then it will never go back to try block. Okay, once it is comes out of this try block, then it will never go back to the try. If you have something to execute also, that will be skipped. So because of that, what we need to do as a best practice, whatever is a risky code, only put that code inside the try block. don't put whatever you want. Okay. So I have 9 lines code. I'll put these 9 lines code inside the do. No, don't do all these things. Okay. Just put only risky code. Wherever you feel that this there might be option or no possibility having exception, only put that logic inside the try block. Okay. So because of that, I'm losing this execution of this statement 4. Right. Printing 4. Right. So output is 1256. Okay. So let me execute this. You see that 1256 and no exception, smooth termination. Right. So fine. Now I have another exception raised statement to the same way, and corresponding handling code not available. So I'm not handling properly. Okay. So now what I'll put here. So this is arithmetic exception. So I'll put IO exception. Okay. So I'll put IO exception. There is no corresponding handling code is not available. Okay. So in this scenario, what will happen? Right. So now, if you discuss about this, so it will come here. It will come here. It will print 1. Okay. So comes in this. It will print 2. After that, you found exception. But this is arithmetic exception. To handle arithmetic exception, I do not have any catch. Okay. No handling code for arithmetic exception. I have a handling code for IO exception, not arithmetic exception. So this is not useful for this exception. So it will not come here. So obviously there is no handling code. So your program will terminate. What terminate? Abnormal terminate. So don't even, it will not execute this out of this catch block also. How we saw without handling code, right? Default exception handler, how it will behave. Here also same thing. 1, 2, abnormal termination. Okay. So now what I'll do, I'll clear this. And what is your output? 1, 2, 1, 2, and abnormal termination. Okay. Abnormal termination. So we'll try to execute and see what happens here now. You see that? What is happening? So here we are seeing, if I put another exception, so whatever we discussed, it is not coming. It is saying, so cannot find symbol IO exception. So for that, what is the mistake I did is we need to import it this class from the java.io. So actually this is IO exception. So even then also, you just observe what happens. You see that IO exception is never thrown in body of corresponding try statement. So you will get something like this. Whatever we discuss is not the correct one. This is not the one we'll expect. So if you do not have any not handling code, so then we cannot put something like this, right? Without handling code, if you put try, catch should be there. Inside the catch, if you put another statement, so what happens? So this kind of issue will come. Exception, our exception never thrown in body of corresponding try statement, right? So this is what we will get, right? The compilation only, it is looking into all these things, right? While executing, it will print all these things, right? But when you compile only, we are getting, so you are using IO exception, but there is no try block respective to this catch. So that is what it is objecting. Okay, exception, IO exception is never thrown in body of corresponding try statement, right? So exception in catch block, another one. Okay, so let me change back to arithmetic and let me remove this. So if it is there also, no problem, but arithmetic exception, fine. But unfortunately, you found something inside the catch. Inside the catch, you have this one. Okay. So there is no rule that inside the catch block you will have a smooth code. We don't know. Unknowingly, we might put some exception code inside the catch block also. Right. So if this is the case, so here you will find arithmetic exception. So it will jump into this. Here also you are getting arithmetic exception. So obviously this is not smooth execution. So, but we'll see what happens exactly. You see that? It is printing 1, 2. You got this problem. So you came here. Here also same problem. Terminated. Nothing. 6 will not print. You see 1, 2 and the exception. Right. 1, 2 and then what? 1, 2 and abnormal termination. Okay. So this is what the execution flow will be. Okay. So different ways, like if you do not have any, if you have try catch block, if you do not have any risky code, it will execute. It will never go to the catch block. If you try executed smoothly, it will never go to the catch block. So once come to the catch block, it will never go to the try block and it will not execute remaining code. Okay. So no exception, smooth execution. So if you have any corresponding handling code, then smooth execution. If you do not have any handling code, then abnormal termination. Here also this one and abnormal termination. Okay. So if you have something in the catch block, then also abnormal termination. How you can handle this one? If this is the case, you again put in the try catch. You can put something like this. Okay. So this is all about the try catch control flow in this program. So it might be different for different programs, but we need to understand how it will execute. Okay. So what could be the possible interview questions from this? So control flow in try catch block. Can you explain with one example? Otherwise, they might give these kind of things and ask you to explain what the output. Okay. So that's all in this video. Thank you. Hi, in this video, we will talk about methods to print exception information. So till now we are saying that exception will occur and will handle all these things. But if I want to print that exception properly on the console, so how many ways you can do and what information you can print. Okay. So there are few methods available to print that exception information. So we'll discuss one by one. So the first one is e.printStackTrace. E is that exception object in the catch block. Okay. E.printStackTrace is one method. E or E.toString method and E.getMessage method. So all these three methods are inside the throwable class because it is the parent class. If it is having these three, all the child classes will also access these methods. So whatever exception you use, so on that exception object, you can call these methods. Okay. And now, so E.printStackTrace. So what exactly it will print? So it will print the name of the exception, colon, description of the exception, and then the stack trace. So if you see one of the examples, you see java.lang.arithmetic exception, that is exception, colon, description of that exception. What is that? Division by 0, and then stack trace. It is happening at this line, in this program, in this line. So this is how you'll get the output when you use E.printStackTrace. So the second one, E or E.toString. So that time it will not print stack trace, but it will print name of the exception and the description of the exception. You see that like this. Okay. So E.getMessage. So it will print only description of the exception. You see division by 0. It will print only this information. Okay. So by taking one example, we'll see all these things. Let me go to Visual Studio Code. So here I have written one exception, one program, methods to print exception information. Inside that main method, I have a try. Inside the try, I am using one exception code, that is it will raise arithmetic exception. So arithmetic exception. So after this, So I'll print that information. So the E means this exception object. Okay. So what is that we are talking about? E dot print stack trace. Okay. E dot print stack trace. So if you try to execute this, sorry, why did I made a mistake? Why it cannot allow here? Sorry, e dot print stack trace you should not put inside the system dot out dot println. Okay, so already print stack trace will contain that output statements, so no need to put that. Okay, you see that methods to print. So we need to compile and execute, it seems. Give me 1 second. So first we'll try to compile. So now you execute this. Now you'll get the exact information. You see, java.lang.arithmetic exception, division by 0, and stack trace where exactly it is coming. Right? We need to compile and execute. If you directly execute, it will give some extra information, but this is the ideal way. So if you execute it from the IDEs also, IntelliJ or Eclipse, you'll get this information. Okay. So now this is one. And the second one is just the print E. Okay. System.out.println. I'll print E. So if you try to compile this and then run this, you see that exception and description, right? No stack trace. So E.toString also it will give the same thing. So internally it will already call toString. If you put exception, explicitly or not, doesn't make any sense. But if you put something like this also, you'll get the same output. Let me try to execute. You see that same information. The other one is E.getMessage. Okay. If you put E.getMessage and if you execute, try to compile and execute, you see that division by 0, only description, right? So with the help of these three methods, whatever information you want to capture, you can capture that information. If you don't want all these stack trace, all these things, you can just go with E.getMessage. If you want everything, you can use E.print stack trace. Okay. So this is how you can use. These are the methods to print your exception information. Okay. So what could be the possible interview questions from here? So what are the methods available to print the exception information and different between these methods? So if you say E.print stack trace, what it will exactly print? If you use E, what exactly it will print? If you put get message, so what it will print, right? So that's all in this video. Thank you. Hi, in this video, we'll talk about try with multiple catch blocks. Okay, so is that possible? For a single try, can we write multiple catch blocks? So if we can write, is there any rules on that? So we'll discuss everything in this video. So we can have multiple catch blocks for single try block. Okay, that is possible. Exception catch block should be the last catch block. So we'll say catch exception E, right? So if you're writing something like that, that should be the last catch block. If you have multiple catch blocks, exception should be the last catch block. And duplicate catch blocks are not allowed. Okay, with the same name, if you have multiple catch blocks, it will not allowed. So by taking one example, we'll see all these things. Okay, let me go to Visual Studio Code. So here I have written one class called try with multiple catch blocks example. So inside this, I'm reading one input, one value from the keyboard using scanner class that we already discussed. So enter the number. I'm giving the number, and here I'm using here that n. This n I am using here 5 by n, right? So, and I'm using catch block. Inside the catch block, I'm using exception class. This is super class, right? It will handle all kind of exceptions. So here I'm printing that exception. That's it. Simple. Okay. So now, if I try to execute this, so it will ask me enter the number. If I put to 2, so smooth execution, 5 by 2, so something like that, it is giving me 2. But if I give 0, you see that you'll get what exception? Java.lang arithmetic exception division by 0, right? 5 by 0, you'll get arithmetic exception. So I'll try to execute again. I'm giving high. Instead of number, I'm giving some string. That time you'll get number format exception for input string high, right? So this is another exception. So with the help of exception, I can handle all these exceptions. So how many exceptions you will get? Everything can be handled with this exception class. Then if it is there, why to use arithmetic exception separately, number format exception separately, IO exception separately? Why we need to write like that, right? So with this simple exception, we can handle everything. We already saw, right? We have given 0, we have given string. So here exactly it is showing what exactly happening arithmetic exception. Here it is exactly saying what exception you will get, number format exception. So why to write separate catch blocks, right? So let's assume the same example. If I put 0, you need to handle in different way. My exceptional, that handling code will be different. Okay. If I give string, my handling code should be different. If I give something else for that exception, my handling code should be different. But here I cannot put those many conditions here. So simply only one means this is same for all the exceptions, not customized for each and every exception. So because of that, we can write different exceptions, right? If you get arithmetic exceptions, this is my alternate code. If you get number format exception, this is my alternate code. That flexibility I do not have with this catch block, this exception class, right? For all the exceptions, I have only single handling code, same handling code. So then now what we'll do, we'll write different catch blocks. Okay. So first let me copy paste this again. Okay. So here arithmetic exception. So here number format exception. Okay. So instead of this, what I'll write here, handling code for arithmetic exception. Okay. So here, so let me copy this. This is number format exception. Okay. So if you have arithmetic exception, it will jump into the arithmetic exception and this alternate code will execute. If you found number format exception, it will jump into the number format exception. It will use this handling code. So I have flexibility for each and every type of exception, right? That is the advantage when you use different exceptions handling code. Okay. So now if I try to execute here, I have given 0. You see that handling code for arithmetic exception I'm getting. So what happened with the moment when it finds arithmetic exception, it will search there is any handling code for arithmetic exception. If it finds, it will jump into that. The same way, if I execute again, so if I give high, you see that handling code for number format exception. The moment it finds number format exception, so it will jump into that and it will execute. If both are not there, so it will use exception. Right. So this is how you can have multiple catch blocks for a single try. And what we discussed, exception block should be the last. Okay, so I'll cut this one and I'll put here in the first. Okay, so let me execute now. You see that I'm getting two errors. One is at this arithmetic exception catch block, another one is number format exception catch block. The reason what it is saying, exception arithmetic exception has already been caught. Exception number format exception has already been caught. So it is already handling, where here it will handle everything, right? Irrespective of arithmetic, number format, IO exception, interrupted exception, XUL exception, whatever it is. So this will handle. But if it is handling, why this code now? What is the use of this code? And what it will do, the moment it finds the exception, that it will go to the immediate catch block first. Okay, here if it is handling, then it will go inside this, it will ignore this, right? If this catch block is not corresponding to this exception, then it will go to the next catch block. But here, this is exception superclass, it will handle each and every exception, then this is not needed. So because of that, it is objecting. Already you are catching that exception, why you need these two? So because of that, you should have this at the end. Then what happens? If it is arithmetic, it will check here. Okay, this is arithmetic, it will go inside this, it will execute. If it is number format, what it will do? It will check here. Okay, this is not the which I'm looking for. So it will go here. Okay, this is what I'm looking for. It will jump here. If both are not matching, then it will go here. It will execute this. But if you put exception in the top, so these are all no use. Because of that, it will throw an error. Sorry, means it will throw error. Now, this point we discussed, right? Exception catch block should be the last catch block. Duplicate catch blocks are not allowed. So frankly speaking, this exception, this one, the previous condition, duplicate only. Exception will handle arithmetic and arithmetic will handle arithmetic. So because of that, it very similar to this kind of, okay. Okay, anyhow, I copy pasted arithmetic exception again, and exception I moved to the end. So if you try to compile now, execute now, you'll get the same thing. Exception, arithmetic exception has already been caught. So you are catching here, then why you need this, right? So duplicate is not allowed, right? Exception should be at the end and duplicate is not allowed. You can have multiple catch block. So with the respective catch block, you can handle different handling code. That flexibility you will have with the different catch blocks. So because of that, you can write multiple catch blocks. Okay, so this is all about try with multiple catch blocks. Okay, so what could be the possible interview questions from here? So is it possible to have more than one catch block for a single try? Yes, we have already seen. Order of catch blocks, we just discussed it, right? Exception should be at the end. Is it possible to have duplicate catch blocks? No, it is not possible. Okay, we discussed all these things with an example. Okay, that's all in this video. Thank you. Hi, in this video, we'll talk about finally block in Java. So what do you mean by finally block? What is the use when you use finally block in Java? So that we will discuss in this video. So Java finally block is always executed whether exception is handled or not. Okay, so if you have any exception, whether you handle or not, finally block will executed always. Okay, so if you talk about one of the examples, so you just take an example of connecting to the database. Okay, connect to the database. So first point, what we will do, we will connect to the database. Okay, Second operation, what we will do, interact with that DB. Interact with DB. Interact means what? Read or write operation. Okay. Read, write operation on DB. And the third one, disconnect. We connected, right? Disconnect to the database. So now when you talk about this scenario, so in real time, connecting to the database will be limited. They will give limited connections to connect to the database. Okay. So if you connect to the database, something happened in between when you're interacting with the DB read or write. So if suddenly some exception happens, so it will terminate, right? It will terminate the program. Then what about this connection to the database, right? So if you did not disconnect to the database, then one connection we will lose, right? If there are 3 connections, but one connection is blocked like this, so only other 2 persons can interact with the DB. So third person cannot interact with the DB, even though there is a possibility of getting the connection to the database just because of this abnormal termination. So that time, whatever it happens, whether it is exception happened, not happened, I want to disconnect the DB at any cost. So that time you will put this code in the finally block. Okay. This code you will put in the finally block, irrespective of exception happened or not happened, handle, not handle, this finally block will get executed. When it is get executed, you will disconnect to the database. If it is disconnect to the database, so you will have that connection open. So other person can use that connection. So what you say, like you handling the resources properly. So effective way of handling the resources. Okay, that will happen. So because of that, you'll use finally. So this is the advantage when you use finally block in your Java. So let me clean this. So it identifies a block of statements that needs to be executed regardless of whether or not an exception occurs within the try block. So that is what we discussed, right? Whether the exception happened or not, this block of code will get executed. It is not mandatory to include a finally block at all, but if you do, it will run regardless of whether an exception was thrown and handled by the try and catch parts of the block. So finally block is not a mandatory block. So, but if you use this, that is the advantage that we just discussed. But if you do not put any finally, nothing, it is not a problem. Okay, that we already discussed in our previous videos, like with the help of try and catch, right? As per the coding standard, in the finally block, we should write resource releasing logic or cleanup code. So that is what we are saying, that resource is blocked because of exception, but that should not happen. So because of that, you put this logic inside the finally block, it will always get executed. If it is get executing, so the cleanup will happen. Otherwise, releasing the resource will happen. So that is one of the best coding standards. The finally will always execute unless. So we are saying that finally block will always execute, but there is an exception to that. In any one of the scenarios, whether it will not execute. So there are few, so that we'll discuss. System.exit is called in the try block. Okay, so system.exit. So when you say system.exit, we are terminating the JVM. So we are stopping the JVM. So if the JVM itself is stopped, so other execution will not happen. Okay, that we'll see with an example. The JVM crashes. So system.exit is one of the way of crashing. It's not crashing, we are terminating. So suddenly because of any one of the reasons, like any crashes happens to JVM, that time also, even JVM is not there. So how, means what it will execute the program, right? So in that scenario also, finally will not execute. The try block never ends. So if you are not coming out of the try block, then obviously finally will not execute, as it is step-by-step process. So if you put some endless loop, there is a loop that is in continuous infinity loop, then it will never come out of that loop. So it will not reach the finally block. So it will not get executed. Okay, so but it will not happen most of the times, but there is a possibility that finally block will not always execute. Okay, so we'll discuss following scenarios to understand finally block. What is that? The case one is no exception raised in try block. Okay, the case two is exception raised in try block and handled in the catch block. So exception raised and not handled in the catch block. So we'll see these three scenarios. We'll try to understand how finally block will execute. Okay, so for that we'll take an example. Let me go to Visual Studio Code. So here I have created one class called finally block example. Okay, and I have a main method. Inside the main method, try, catch, and then finally. So this is the sequence, right? Try, catch, finally is the sequence. First try, then catch, then finally. Okay, without catch can't I write finally? Okay, so can we put other alternate, means the order is different order. So there are few things we need to discuss that we'll discuss in our upcoming videos, but here at a high level it will be try, catch, finally. Okay, exceptions we'll discuss later. So now in the try block I do not have any exceptions, just a system.out.println, right? And catch, and then system.out.println, and finally block I just used finally block, and we discussed irrespective of any exception finally block will get executed. Okay, so in this scenario there is no exception raised in try block. So what is the execution order and what could be the output? Okay, so when you start executing, it will jump into the try block, so it will reach. So obviously there is no exception, it will print this. If nothing happened in the try block, no exception, then it will never go to the catch. So it will not execute this line in catch block. But we discussed just now, finally it will get executed always. So then it will come here, it will execute this, so it will execute. So in try block, in finally block, will see in the output in this scenario, that is case one, no exception raised in try block. So we'll try to execute and see. Java try finally block example.java. You see that in try block, in finally block, it is executing try block and finally block. The reason is there is no exception. If there is no exception, it will not go to the catch. So because of that, it is skipping this statement and it is jumping into the finally and it is printing this. Okay, now exception raised and handled the exception. So exception raised means, so we'll put one exception, arithmetic exception. So instead of this statement, I'll put an arithmetic exception 5 by 0. So we know that if you put 5 by 0, division by 0, then you will get an arithmetic exception. It will raise an arithmetic exception. So let it be this one also. Okay, let it be this statement. So if this is the case, what happens? The moment it reaches this try block, so first it will print this one. Then it found exception. So respective handle code is there. Yes, arithmetic exception catch code is there. So it will jump here. So now it will execute this. So it will print this one. Even though if there is an exception, it went to the catch. Even though finally will get executed, that we already discussed, irrespective of any exception, finally will get executed. So that is the advantage when you use finally. Okay, so now it will print in try block, in catch block, and in finally block. Okay, so now we'll try to execute and see. You see that in try block, in catch block, in finally block. So 3 statements. The reason is we have an exception and that is handled. So if it is handled, so it will come here and it will execute the code inside the catch and it will reach the finally and anyhow it will execute. Because this is what exception raised and handled. What about exception raised and not handled the exception? Okay, so not handling means if I'm getting arithmetic exception, but I do not have arithmetic exception. So I'll comment this. I'll write another block. What is that block here? I'll put number format exception. Okay, I'm not handling arithmetic exception. I'm handling number format exception. So the moment when it reaches here and it finds arithmetic exception, it will search for the respective catch block, but there is no respective catch block. So there is no handled code. Then obviously what will happen? What will happen? Abnormal termination. So even though there is abnormal termination, before printing means raising abnormal termination, it will reach finally and it will print this one. So then it will print in try block, in finally block, then arithmetic exception. Okay, that is the sequence. So we'll try to execute this and see. You see that in try block, there is no catch. So it went to the finally block, respective message exception, message and abnormal termination. Okay, Java and lang that arithmetic exception division by 0, where it is in the 5th line. Right in the 5th line. So that is how finally block will get executed, and the use of final block is if you have exception, if you do not have exception, if you are handling, if you are not handling, irrespective of all these scenarios, finally will execute always. Right. So most of the times it will be like this, but we discussed some exceptions. All right. So what are those? So in these scenarios, so JVM crash, I cannot show, I cannot crash that, but we can see system.exit and try block never ends using endless loop. So first we'll use system.exit. Okay. I'll put system.exit in the, so instead of this, so it will accept any integer. If it is 0, normal termination. If it is other than 0, abnormal termination. That you cannot see, that will happen internally. That we cannot see on the console. So, but system.exit is you are terminating, you are shutting down your JVM. Okay. If here JVM shutdowns, then how it will go to the next lines? Right. Because of that, finally will not execute. So if you see, now we'll try to execute this. You see that it is printing in try block, but it has to go here, right? It has to go here. If it is not going catch, that is fine. But if it has to execute always, that we discussed, but now it is not happening because of system.exit. This is one of the exceptions. In this scenario, finally will not execute. Okay. So if you put something else instead of 0, if you put some -150, even then also you will not see any difference. But internally there is a difference, but normally you cannot see. Now, this is one thing. The second thing is in the try will go into the infinity loop. Okay. So we'll see that. So I'll comment this code. I'll write a logic while loop 1 greater than 0, and then system.out.println, I'll write in while loop. Okay. So this condition never become false. 1 is greater than 0, right? If 1 is greater than 0, it keep printing this statement in while loop, in while loop, in while loop, something like that. So it will never end. So if it is in infinity loop in try, it will never go to the finally block. Right. It has to come out of this loop, right? Try block, right? Then only you will reach finally, but it will never come out of this loop. So it will never come out of this try. So it will never reach finally. Okay. So we'll try to execute and see. You see that it keep printing in while loop only, infinity. So you need to terminate manually, right? Forcefully you need to terminate. Control C. Okay, Control C, it terminated. But you see, in while loop only, it never reached finally. The reason is we terminated manually, forcefully, right? So otherwise it will be in this loop only. So let me comment the code. Okay, in system.exit, in infinity loop, it will not reach finally. Those are exceptions. If JVM crashes, okay. So this is all about finally block. How it will execute? It will execute always, irrespective of exception happened or not happened, handled or not handled. But there is some few exceptions. That is system.exit while loop means some infinity loop. Then only it will not reach finally. Okay. So these scenarios will not happen frequently. It's a very rare scenario, but as we are discussing finally, I'm just telling you these are exceptions. Okay, so this is all about finally block. So what could be the possible interview questions? So what is finally block? Purpose of finally block, specialty of finally block, exceptions to finally block. So all these things we just discussed. So that's all in this video. Thank you. Hi, in this video, we will talk about try catch finally control flow, how the control flow will be in when you use try catch finally. So with the help of some cases, we'll try to understand how the exactly control flow will be when you use try catch finally. So for that, let me go to Visual Studio Code. And here I have already created one class called try catch finally control flow example. So inside that I have a try block, catch block, finally block. Okay, inside the try I have 3 statements. In the catch I have one statement. In the finally I have one statement. Outside of all these things I have one more statement here. Okay, so I have few cases here. So we'll see first. So no exception in try block. So how the output will be, how the flow will be, what is the output? If an exception raised at statement 2 and corresponding catch block matched. Okay, so there is an exception in statement 2 and corresponding catch block is there. And if an exception raised at statement 2 and corresponding catch block not matched, okay, then what could be the flow and what could be the output? If an exception raised at statement 4, if an exception raised at statement 5, if an exception raised at statement 6, 4 where it is in the catch. In the catch also there is an exception raised. In the finally block also, if exception raises. Outside of all these things, right, there is no try catch block here. So here if you have any exception here, how the execution will be. Okay, so we'll try to execute and see how it will be. So before that, if no exception in try block, so how the execution will be? So if there is no exception, so it will come to the where here it will execute 1, 2, 3 in the try block. There is no exception, then it will never go to the catch. So it will not execute statement 4. Finally will execute always. So it will print this one. So once you come out of that, it will print this one as it is. There is no exception, nothing. And then smooth execute, smooth termination. Right, there is no exception means smooth termination. Right, so that will happen. So let me clear this. And I'm expecting output is 1, it will print one statement 1, and 2 and 3. It will not go to the catch, so 4 is not there. 5, 6, smooth termination. Okay, so let me go to the command prompt, Java file name.java. You see that statement 1, 2, 3, 4 is not there, so it will not go to the catch as there is no exception. Statement 5 from the finally, statement 6 out of all these things, and there is no exception, smooth termination. Right, this is one thing. So if you have, if an exception raised at statement 2 and corresponding catch block match. So in the statement 2, what I'll do, I'll raise an exception. So what I'll do, I'll put one arithmetic exception, 5/0. So what happens here? Once again, if you talk about this thing, so first it will come, statement 1 will execute. Then it will come here, it will raise an exception. So it will search for corresponding catch block. So if this is arithmetic exception, we have arithmetic exception. So it will come here, it will execute this one. Okay. So after this, anyhow, it will go to the finally, it will execute 5, it will execute 6. We have handled the exception. So smooth termination. Okay. So 1, 4, 5, 6, smooth termination. So let me clear this and we'll try to write here. What is that? 1, there is no 2. So if you have some exception, it will not execute the remaining statement. So 3 will also not there. So it will go to the catchback 4 and it will go to the finally. So it will go to 6, then smooth termination. Okay. So we'll try to execute and see whether we are getting the same output or not. You see that 1, 4, 5, 6 and smooth termination. So that's how the flow will be. Okay. So the next is, what is that? If an exception raised, its statement 2 and corresponding catch block not matched. So this is not matched. So what I will do, I will change it to something else. So number format exception. Okay. The same thing, it is number format exception. Now how the execution will be. So first it will come in the try. So first it will print 1. So but it founds an exception at statement 2, 5/0, that is arithmetic exception. It will search for any arithmetic exception catch block. So there is no corresponding catch block. So it will not come here. So statement 4 will not execute. So whether irrespective of anything, it will come to the finally, right? So you will get this 5, right? You will get this 5, but it is abnormal termination, right? So because of that, it will not execute 6. So abnormal termination. It will print only 1, 5, then exception. It will print an exception. If it is printing an exception, means abnormal termination. So what it will be? Let me print that. 1, 5 and then abnormal termination. Abnormal termination means it will print that exception. What is that exception? Okay. You see that 1, 5 abnormal termination, 1, 5, and then there is an exception we did not handle. So it is printing that exception here. So because of that, this is abnormal termination, right? That is how the flow will be. So now another, if an exception raised at statement 4. Okay. If an exception raised at statement 4. So let me put this back. So I'll not raise this here. Control C, let it be, but so it raised at this statement 4. Right. So how it will be? So let me take this annotation. So first it will come here. In the try block, I do not have any issues. So it will print 1, it will print 2, it will print 3. Then when you come here you found arithmetic exception, but we are not handling. There is no catch block, there is no try block, right? So then we are not handling. It will have abnormal termination. Even though if it is abnormal termination, it will go to the finally. So it will print 5. So 1, 2, 3, 5 abnormal termination, right? 1, 2, 3, 5, then abnormal termination. So we'll write all these things and we'll try to execute and see. So here 1, 2, 3, 5, abnormal termination. Okay, 1, 2, 3, 5, abnormal termination. So we'll try to execute that. What we did. System.out.println at 5 by 0. And then there is no handling code. So it has to come this way. I did not save the program, it seems. So let me execute again. Why it is giving 1, 2. So we made a mistake, like it is executing properly. The reason is, if there is no exception in try, it will never go to the catch, whether you have exception or not. What we need to do, we need to go to here. If you want to go here, you should have a 5 by 0 here, and I'll put arithmetic exception. Okay. So in the statement 3, I do not have statement. Otherwise, we'll do one thing. We'll put like this. Okay. So 1, 2, 3. Then there is a exception. So it will go to the catch block. Here also exception. So it will terminate, abnormal termination. So before that, it will print 5. So that is what we saw, right? So 1, 2, 3, 5, abnormal termination. So we did not go to the catch block, right? Because of that, there is a smooth termination. Yeah. 1, 2, 3, 5, 1, 2, 3, 5, and then abnormal termination. So that is how it will be. If an exception raised in statement 4, if you want to raise an exception in statement 4 here, first you have to go there, right? If you want to go there to the catch, we have an exception. You should have an exception in try. So then it came here. So here also there is no handling code. So because of that, it is raising. Before that, it is printing all these statements. That's how the flow will be. Okay. So now, what is that? If an exception raised at statement 5. Okay. Statement 5. So let me comment here. Let me comment here. So this exception I found at here. Okay. In the finally. If it is in the finally, how the flow will be. Okay. So if I try to annotate here, we'll see. So normally it will come in the try. In the try, I do not have any exceptions. 1, 2, 3, no problem. So it will not come here. So it will come here anyhow. Here we have what? Abnormal termination. Right, there is no handling code. So abnormal termination. If it is abnormal termination, it will never go to the next statements. So what could be the output? 1, 2, 3, abnormal termination. Okay. So we'll see 1, 2, 3, abnormal termination. Let me clear this. Let me write that one here. 1, 2, 3, abnormal termination. Okay. This is case 6. So if you try to execute this now, you see that 1, 2, 3, then abnormal termination. It is raising arithmetic exception. We are not able to handle there, means we do not have try catch in the finally. Right. So because of that, it is raising abnormal termination after printing 1, 2, 3. So if this is the case, at this line number in statement 6. So I'll comment this out. I'll put here. Okay. So now we'll try to see how the execution will be. So it will come to the try. So obviously 1, 2, 3, there is no exception. It will never go to here. So it will not print 4. Anyhow, finally will execute. So it will print 5, 1, 2, 3, 5. And then here, arithmetic exception, but there is no try catch anything. So here abnormal termination. 1, 2, 3, 5, then abnormal termination. So we'll see by executing this. First, we'll try to write the output 1, 2, 3, 5, abnormal termination. Okay, let me execute this. You see that 1, 2, 3, 5, then abnormal termination, right? So this is how the flow will be. You can try multiple combinations, but just to show how it will be, so I have taken 6 cases. One is no exception in try block. If an exception raised in statement 2 and corresponding catch block match, corresponding catch block not match. If it is the exception raised in the catch block itself, if the exception raised in the finally block, if the exception raised at the outside of all these things, how the flow will be. Okay, this is how try catch finally control flow example. So what could be the possible interview questions from here? So control flow in try catch finally, they might give some one of the examples like this. They might ask what could be the output of that. Okay, so that's all in this video. Thank you. Hi, in this video, we'll talk about nested try catch blocks. Okay, so is it possible to nest the try catch blocks? Means inside the try, I can use try catch again. Inside the catch, can I use try catch? Inside the finally, can I use try catch? So that is possible. So by taking one example, you'll understand this. So let me go to Visual Studio Code. So here I created one of the classes called nested try catch blocks example. Okay, so here in the main method, I used one try. Inside the try, I have try catch block. And after that, for this try, I have a catch block. And then I have a finally block. Okay, so inside the try, I have another try. This is called nesting, right? Nesting the try catch block, nested try catch block. So now, if this is the case, what could be the output? Okay, if this is the case, what could be the output? So first it comes here. So inside that, I do not have any exception code. This is just a system.out.println. So outer try. So it will print here. So then it will jump into the try block, right? So inside the try block, I have inner try. There is also no exception. If there is no exception, it will never go to the catch block. So it will not execute this. So then once the try catch completes, there is another statement after inner try catch. Okay, so it will print. Then it will not go to this catch block. The reason is in the outer try, I do not have any exceptions. So it will never go to here. So finally always executes. So it will be finally. So 4 statements it will execute: outer try, inner try, after inner try catch, and finally. So 1, 2, 3, 4. So we'll try to execute and see whether it will print or not. The same thing. So let me copy this. Java file name.java. You see that this is matching outer try, inner try, after inner try catch, finally whatever we marked as right symbol. So we are seeing the same output. Okay, if there is no exceptions in the program. Okay, so now if you take an exception at inner try, okay, in the inner try, I'll put an exception. So the same thing, 5 by 0, always I will take the same example, right? 5 by 0 for arithmetic exception, 5 by 0. So now how the execution flow will be. Okay, so if you take like this, obviously there is no issue in the try, it will print this. So the moment when you come here in the try, there is an exception, that is arithmetic exception. So it will search for the respective arithmetic exception catch block. So it found here. Okay, so it will print inner catch. So anyhow, it came out of the try catch. So it will print after inner try catch. So it will never go to this because of the outer try, we do not have any exception. It will not print. Then anyhow, finally it will get execute. Here also 4, but outer try, inner catch, after inner try catch, then finally. So we'll try to execute this and see how the execution will be. So let me save this. You see that outer try, then inner catch, after inner try catch, and then finally. Right. No issues. Inside the try block, you are writing the try catch block, and you are seeing some permutations, combinations, how it will execute. Okay. So let me clear this, and we'll try one more. So let it put it back as usual, normal flow. So now what I'll do, so let it be like this, the same thing, but here arithmetic exception happened, but there is no arithmetic exception. Corresponding catch block is not available. So number format exception I'm using. Okay. So number format exception. If it is number format exception, so what it will do, we'll see how it will be. So there is no issue outer, so it will print. So here you found, what is that? Number format exception. So if it is number format exception, so it will not print, it will come here. So this catch block will not go, as I'm expecting arithmetic exception, but I found number format exception, so it will not go here. So after that means here abnormal termination. So it will come out. So it did not find, it means not abnormal termination, but with respect to here, abnormal. So what happens if it is not there inside the catch? So outside the catch, it will go. This is exception. Exception is parent of other exceptions. So it will handle the arithmetic exception also. So it will print outer catch. So outer try, then outer catch. Anyhow, finally this one. Okay. So we found arithmetic exception here, but respective arithmetic exception catch here, not there here. So it will not go here. So it found somewhere where outer catch. So it came here, it found this exception. So it will go inside, it will print outer catch. Finally, anyhow, it will execute, So 3 statements it has to print. So I am correct or not, we'll see by executing. You see that? So first outer try. After that, outer catch. You see outer catch, finally. Right. We are handling with the help of this catch block. So there is no abnormal termination. Okay, smooth termination only. But here there is no respective catch block. So it came out outside of try. So immediately it found catch, and it is parent exception. It will handle everything. So you'll print the outer catch. Right. This is how the flow will be. If it is not matching here, if it is matching outside also, it will take care of that. Okay. Let me clear this. So now what we'll do, we'll try to put in the, so let me put everything here properly. So no exception, nothing. So I'll put it back arithmetic exception. Okay. So now I will move this arithmetic exception to catch block. Okay. Where catch block? This catch block. So if it has to come to the catch block, there should be some exception. So I'll put the exception as it is here. Okay. I'll put the exception as it is. Let me comment this for some time. Okay. So if there is no exception, how it will go to the catch? So because of that, I put exception here. So it will come here. So we'll see how the exception execution will be. So if you take here outer try, it will execute. So it comes here in the try. So immediately it will search for the arithmetic exception. I found arithmetic exception, right? So because of that, I'll change it to what number format exception before that. Okay, number format exception. So now again, so 5 by 0 is arithmetic exception. So respective catch block is not there. So it will not go here. it will not print here. So obviously it terminated here, so it will not print this one also. So it will come out of this try, but it found parent exception, so it will go inside this. But when you go inside this, there also one arithmetic exception. If it is arithmetic exception, what happens? Abnormal termination. Before abnormal termination, there is a finally block. It will execute this one. So outer try, finally, then arithmetic exception. Outer try, finally, then arithmetic exception. Okay. So we'll try to execute that. We'll see how it will be. Whatever we discussed came or something else. You see that? Outer try, then finally, then arithmetic exception. Okay. So this is how the flow will be in the nested try catch. So you can put this try catch inside this try catch. You can put another try catch inside the catch. Also, you can put try catch for this to handle this one. So inside the finally also you can put try catch. So there is no rule that, right? In the catch also sometimes there might be a risky code, right? So because of that, you can put this nested try catch in anywhere. Okay, just by taking this small example I explained, but this try catch you can put inside this, inside finally also. But you need to understand how the flow is going. Okay. So that's all in this video. So what could be the possible interview questions from here? So is it possible to use try inside the try? Yes, we can do that. We had just saw that. Nested try catch is possible or not? Yeah, it is possible. You can put that nested try in the try, in the catch, in the finally also. Okay. So that's all in this video. Thank you. Hi, in this video, we'll talk about throw keyword in Java. So what is throw keyword? What is the purpose of this? How to use this? We'll see by taking few examples in this. So before going to the examples, first we'll see the theory. So throw keyword in Java is used to throw a built-in exception or a custom exception explicitly or manually. So throw keyword is used in Java to throw a built-in exception or a custom exception which you write your own. Okay. So with the help of throw keyword, you can throw your custom exception. Even though you can do built-in exception also, but that is not needed. Like already this is built-in exception, but you can do both. Okay. But the purpose is to throw the custom exception explicitly or manually. Using throw keyword, we can throw either checked or unchecked exceptions. You can do both. When an exception occurs in the try block, throw keyword transfers the control of execution to the caller by throwing an object of exception. So the moment a throw will throw, what is that? The exception object. Okay, that we will see. Only one object of exception type can be thrown by using throw keyword at a time. So by using throw keyword, you can throw only one object of exception, not more than one. So by taking one example, we'll see all these things. So throw keyword can be used inside a method or static block provided that exception handling is present. Okay, the throw keyword can be used inside a method or a static block. Throw keyword is used for customized or user-defined exceptions, but not for predefined exceptions. So we just discussed that it can be used for both, but the purpose is to throw user-defined exceptions. Okay. Throw keyword only for throwable types. Otherwise, we will get compile time error saying incompatible types. So when you using throw keyword to throw any exception, the class should be of type throwable. Means what? It should be child class of throwable. Okay. So then only you can do. Otherwise, you will get compile time error saying incompatible types. By taking one example, we'll see that also. Here, I have taken one diagram. So here, if you see, so here I have created like, this is the syntax. Throw is a keyword, this keyword, throw new arithmetic exception, and you can write your own message, division by 0. Whatever you can put, how exactly it will give by division by 0, right? That also you can put. But here you have choice, whatever you want to put. So new arithmetic exception. Here this is inbuilt, right? Inbuilt, just to show an example, right? But The throw is normally for your user defined exception, but this is inbuilt exception. We can use for both, but already we can handle this using catch all these things, right? But throw is used explicitly to throw user defined exception. But to show an example, I have taken the predefined inbuilt exception. So throw new arithmetic exception in the bracket. So you will write some information to pass or to show to the user. Okay. So here, new arithmetic exception. The new keyword is to what? To create the object, right? So here, creating on arithmetic exception object manually or explicitly. With the help of new keyword, I am creating an arithmetic exception object explicitly. And what it will throw will do? What throw will do? It will hand over the created object, this object. So this object, whatever we created, this to hand over the created object to the JVM manually. So the throw keyword, what it will do? The created object handovers to the JVM. Okay. So what is this? Only arithmetic exception. This class should be of type throwable, right? Arithmetic exception is throwable, right? It is child class of exception. Exception is child class of throwable, right? So it is of type throwable, means child class of throwable it should be. Otherwise, if it is not child class of throwable, then you will get incompatible type at the compile time that we just saw one of the points, right? So this is how it will be. So we need to use throw new that any exception, user defined exception of, and you can put whatever customized message you want, right? Throw will hand over the created object to the JVM. So this class should be of type throwable. Okay, you need to remember these points. Okay, so by taking one example, we'll see all these things. So let me go to Visual Studio Code. So here I have created one of the classes called throw keyword example. Okay, so here I have written simple thing. What is that? System.out.println 5/0. I'm not using any try catch. So how it will be handled? So in one of our previous videos, we have seen default exception handler. JVM will delegate this in what you say, like this task to default exception handler. So that will take care of that, and it will print arithmetic exception. So let me execute Java throw keyword example.java. You see that? Divide by 0 arithmetic exception, right? That we already saw. But I want to throw my own exception. I want to throw my own exception that is not known by Java. Java will know only predefined, right? Runtime exception, SQL exception, all these things, whatever we saw, only that can be handled. But sometimes I want to throw my own exception. So I have different purposes, but Java might not give all the exceptions which I want in the real time. So I can create my own exception. How to throw that? Okay, so I'll not use this. So we'll use what? Throw is a keyword. New arithmetic exception. Okay, arithmetic exception. So I can give whatever I want here. So normally how it will be? Division by 0. Okay, so I'll give the same thing here. That's it. It is not happening because of 5/0. I am explicitly throwing divide by 0. There is no logic even. Okay, but just to show how it will work, we are doing this. So let me go back to that command prompt. Let me execute this. So this is a typo, THROW. You see that the moment when it is keyword pink color, so there is a typo. I put THRW. You see that arithmetic exception. What I'm raising arithmetic exception, I'm getting the same output. Okay, we'll see by changing this one whether it is coming from here or by default it is taking. Okay, so I'll put my own division by 0. I just customized a little bit. Okay, so if we try to execute now, same thing, but the message will be different. You see, whatever I have given, this one arithmetic exception. Why I'm getting arithmetic exception is a child class of throwable. Because of that, I'm not getting any issues. So this is how you can throw your own exception. Okay. Now, if it is not of type, okay, if it is not of type throwable, then how the, what is it, issue will be, how the output will be. So let me take this one. Let me take this one. Okay, change it this. I need some class, right? And this class should be of type throwable. So, but this is not a throwable. I have written my own, but it is not of throwable. So if I try to execute this now, okay, if I try to, okay, what I'll do, I'll copy paste this. So new, this exception, okay, and I'll put my own, this is my own exception. Okay, this is my own exception. I'm raising. Okay, this is how I can throw. When you throw, it will create an object of this throw keyword example as it is a class with the help of new keyword. This object is handed over to the JVM. So JVM will print that, means take care of that. So the rule what we discussed here, so this class, whatever the class you are using, this class should be of type throwable. Okay, but means child class of throwable. But this is, I created one class, randomly given one name, throw keyword example. This is not of type throwable. So if this is the case, what will happen? We just discussed that it will say incompatible types. Okay, so let me execute this. You see that throw keyword is class cannot be applied. Sorry, there is no constructor, right? So I cannot give this one. Okay, I cannot give this one. So don't give this one. Okay, just throw like this. Okay, if you want to put something like that, there should be parameterized constructor, right? That is not there. You see that error, incompatible types. Throw keyword example cannot be converted to a throwable, right? It cannot be converted to a throwable. The reason is it is not of type throwable. It is not a child class of throwable. Because of that, you will get incompatible types. So that is we need to remember. So how we can make it type of throwable, means how can make it child class of throwable. So just extend that throwable, extends throwable. Right, now it became what? Child class of throwable. Now it is of type throwable. So if you try to execute now, okay, if you try to execute now, you will not get the incompatible types. You see that? Unreported exception. We do not have something, anything is not there. So unreported exception, throwable one must be caught or declared to be thrown. Okay. So frankly speaking, there is no exception. We do not have any implementation for this. I'm just using. But if it is not of type throwable, then you will get incompatible. If it is of throwable, so it is saying error unreported exception. Must be caught or declared to be thrown. Okay. So you will get this compilation will fail. Compilation failed because of there is no such exception, no implementation. Okay. So that we will see in our next videos. But to understand that it should be of throwable, then only you can use. Otherwise, it will say incompatible type. And with the help of throw, I can throw my own, because I cannot show like this, right? I did not implement it. So because of that, I have taken already implemented exception, arithmetic exception. Okay. So this is how you can use throw keyword to throw your own customized exceptions. Okay. So that's all about throw keyword. So what could be the possible interview questions from here? So what is throw keyword? Purpose of throw keyword. Okay, throw is to what? To throw your customized exception. That is the purpose. Okay. So that's all in this video. Thank you. Hi, in this video, we'll talk about throws keyword in Java. So what is throws keyword in Java? We'll discuss all these things in this video. So before that, we'll see theoretically what is throws keyword. So if there is any chance of raising checked exception in the program, then we should handle either by try catch blocks or by throws keyword. Otherwise, the code will not compile. So we already saw in our previous videos that there might be a chance of raising some exceptions in our code. When there is an exception, then we need to handle that using try catch block that we already discussed. There is another way to handle this, that is using throws keyword. Okay. Throws is a keyword in Java which is used in the signature of the method to indicate that this method might throw one of the listed type exceptions. So this is a keyword to throw an exception. Okay, throws is a keyword in Java which is used to signature of the method to indicate that this method might throw one of the exceptions. Right. With the help of an example, you'll understand everything. But throws is a keyword to handle exceptions, and it will be at the method level as a signature. Okay, used in the signature of the method. So how it will be associated with that method, we will see with an example. Throws keyword will delegate the responsibility of exception handling to the caller method. Okay, so the method which is having exceptional code, that method is responsible to throw exception. Okay, so that is what throws keyword will delegate the responsibility of an exception handling to the caller method. Throws keyword only used for checked exceptions. So it is only used for checked exceptions. Throws keyword only for throwable types. Otherwise, we will get compile time error saying incompatible types. Okay, so everything we'll see by taking one example. So throws keyword only for throwable types. Otherwise, we will get compile time error saying incompatible types. Throws keyword only for constructors and methods, but not for classes. So already we saw in one of the previous points that is associated with the method signature, not with the classes. Okay. So if you talk about this one, the syntax, how the syntax will be. So access modifier, return type, then method name. So that is the keyword you see that here throws. So let me, so here you see that throws keyword. This is the throws keyword. It is associated with this method. Okay. So then you need to mention which exception you are expecting. Exception type 1, exception type 2, something like that. So from the above syntax, we can use throws to declare multiple exceptions also. This is not only for single exception. So you can handle multiple exceptions also with the help of throws keyword. You see that exception type 1, exception type 2, and etc. Okay. So first we'll go to the Visual Studio Code and we'll try to see few examples to understand what exactly we discussed. So let me go to Visual Studio Code. So here I have taken one of the classes called, let me close other things. So throws keyword example. So this is normal try catch block. This is what we have already seen in our previous videos. If you find an exception here, thread.sleep. So we are able to handle that using interrupted exception. Thread.sleep will throw what interrupted exception, then you can handle. So first we'll try to execute this and we'll see what exactly it will do. Okay. Java C program name dot Java. So I did a mistake. This one. So one more is missed. Let me compile again. You see that it compiled properly, no issues. The reason is, so we are handling that exception, okay, using try catch block. But we are discussing about throws keyword. So how it will be? So for that, we don't need to use try catch blocks. Okay, we'll remove this. I will remove this. So this is a simple program. In the main method, I'm just mentioned thread.sleep. So it will raise an interrupted exception. So if you try to compile now, you see that unreported exception, interrupted exception must be caught or declared. So with the help of throws keyword, okay. So at the method level, throws is a keyword. So interrupted exception, right? So this is how you need to mention. This is the syntax. So it is at your method level, so not to the class. So now it should not throw any exception. When I compile this, you see that it is compiling. Means we are able to handle with the help of throws keyword. We are handling these exceptions. So without try catch block, this is another way to handle the exception. Okay. So now, if I take any other examples, okay. So let me take another example. Right. I'm just trying to read data from one of the text files. If this is the case, okay. If this is the case, if I try to compile, now you'll get an error saying, so first I need to use scanner and file. For that, I need to import this java.util for scanner class, java.ivo for file class. So if I try to compile now, you see that unreported exception, file not found exception, right? But I'm handling interrupted exception. So we need to change file not found exception. I'm not writing any try block and catch block. So now it will compile without any issues. You see that it compiled. So with the help of throws keyword, you can handle your exceptions. Okay. So now we need to discuss one more thing. So let me cut this code and put here as a let it be like this. So now let me take one example. So here I'll take method 1. Okay. From the main method, I am calling another method called method 1. So then I'll create method 1. So public static void method 1. So inside this, I'm calling another method, method 2. Okay. So now I'll create this method, public static void method 2. So inside this, I have thread.sleep of 1000. Okay, just an example. So obviously we know that it will raise interrupted exception, but I'm not handling anywhere using try catch block. So and we discussed using the throws keyword. Okay, throws keyword, you can handle this, and we have seen that throws is this wherever you get the exception. So the caller method is responsible to handle this. Who is calling this thread.sleep? So method 2. So method 2 is responsible to throws this exception. So fine, I'll just, so first without throwing any exception. So first we'll try to execute this and we'll see the behavior. So no exception code there. You see that at line 14. So at line 14, I'm getting unreported exception, interrupted exception, right? So that we expected. Now I'll use throws interrupted exception here, right? So now I'm handling this using throws keyword. Now see the behavior. You see that at the 10th line, you see 10th line where I'm calling this unreported exception, interrupted exception must be caught or declared to be thrown. So the problem here is problem, or we can say this is the way how it will behave. So method 2 is method 1 is calling method 2. So method 2 is raising this exception. Obviously, method 1 also should handle this. So because of that, we need to put this syntax or throws here also. So calling method is responsible for that, right? So method 1 is calling method 2. So because of that, method 1 also should handle this exception. So now if I try to execute this now, you see that when I execute first, it will be on the 14th line, then 10th line, now 6th line. Why 6th line? 6th line is calling method 1. So it is throwing an exception. So it should be handled by who is calling this method. Main method is calling this. So again, we need to use the same throws interrupted exception here also. Now if you try to execute, you see that it is compiling perfectly. So if you use throws interrupted exception, if it is called by another method, that is called by another method, how many methods are attached means there is a link between these methods. Those many methods has to throws this. Means it has to throw. So that is one of the weird thing. So then the best way is to handle this is try catch. If it is try catch, only in this method is enough. No need to handle something like this. Okay. So better way to handle these exceptions is try catch, but this is also one of the another ways. Okay. So if you remove any one of the link, if I remove here in between, even then also it will not execute it. You will get the compile time error at the line number 10. Okay. So the chain should be there from here to here, from here to here. If the chain breaks anywhere, you will get that exception. Okay, this is how we need to handle this exception if you calling a method inside another method. Okay, so that is one thing. And what about user defined exception? Okay, so user defined exception, we have seen that how we can do that, user defined exception, and that exception should be of throwable type. Okay, so I will remove all these things. So let me remove, otherwise let me comment this code. I'll just throw an example. I'll show you an example, simple thing. So I will write public static void main. String args. So what type of exception this is? I'm raising this is it's the same class. Throws this exception. Okay, throws this exception. So, but this is not of type throwable. So obviously it will not execute smoothly. So we'll observe the behavior. You see that incompatible types. We already discussed this. So throws keyword only for throwable types. Otherwise, we will get compile time error saying incompatible types. Right. That is what we are seeing here. Incompatible types. Okay. So because this class is not a child class of throwable. So then what I can do? Extends exception or throwable, whatever it is, means it should be a child of these classes. So if I compile now it will compile, no problem. You see that it is compiled. The reason is now this is of type throwable or exception. If you put throwable also, no problem. It should be a child class of throwable or exception or any exception. So if you give runtime exception also, okay, I saved and I compiled. So no issues. So this class should be child of any one of these exception classes. Then this is user defined exception and we are able to use that. Okay. So this is the usage of throws keyword in Java. With the help of throws keyword, you can handle the exceptions. Okay. So what could be the possible interview questions from here? What is throws keyword? Purpose of the throws keyword. Okay. So that's all in this video. Thank you. Hi. In this video, we'll discuss about final versus finally versus finalize. Okay. So what is final? What is finally? What is finalize? In our video series, we did not see finalize yet, but we discussed about final and finally. So what is finalize? What is the difference between these three? We will see with a few points. Okay. So first we'll talk about finally. Sorry, final. So final means when you talk about final keyword. So final keyword in Java is used to restrict the usage or modification by other classes or variables. So basically to restrict something, we will use final keyword. What is those kind of restrictions? So final is the modifier applicable for classes, methods, and variables. So it is applicable for these three classes, methods, and variables. So we'll talk about this restrict point. So if a class declared as final, then the child class creation is not possible. So if a class is declared as final, then you cannot extend that class. So you cannot create child classes for that. So you cannot make it a parent class. Okay, that is the restriction you can do with the help of final keyword. And then if a method is final, okay, if a method is final method, then you cannot override that method. Okay, that is not possible. So you cannot override that method. If a variable is final, okay, if a variable is final, then you cannot reassign that variable. Reassignment is not possible. Means you cannot change the value of this variable. So this is all about final keyword. Okay, that we already saw in one of our previous videos also. So if you talk about final, basically for the restriction purpose. So at the class level, if you use that, you cannot extend that class. If you use at method level, you cannot override that method. If you use at variable level, you cannot change that value, variable value. Okay. So what is finally? Okay. So final is a block. Okay. Final is a block in exception. So final is a block always associated with try catch to maintain cleanup code. Right. We have seen that you open a database connection. Okay. You used that connection. And then you want to close the DB connection. Okay. This kind of cleanup code you will put in the finally block, and it will execute irrespective of anything happened. Okay. Finally will execute always irrespective of whether exception raised or not raised, or whether you handle that exception, you did not handle that exception. Irrespective of all these things, this block will get executed. So you can close the DB connection, you can release the resources. Okay, that purpose we will use finally block. Now we'll talk about finalize. So if you talk about finalize is a method in Java. Okay, it's a method. Finalize is a method. So what is the purpose of this method? So finalize always invoked by garbage collection in Java. Okay, garbage collection in Java. So garbage collection will use this finalize method to destroy an object. Okay, if there is an object already created as part of Java program, you will create so many objects. So sometimes some of the objects are not used in, it means we are not using those objects, just created and there is no reference to that, and we are not using for any purpose. So it will find these type of objects and it will destroy those objects. So it will perform cleanup activities. Okay, so to perform that, garbage collection will call finalize method. Okay, this finalize method will destroy these unused objects in Java. Okay, so this is what finalize method. So this is the difference between final finally and finally. Frankly speaking, there is no relation between all these things, but the name is very close to means no each one, like final, finalize, and no finally, all are very similar. So matching with one name to another name. So because of that, people will ask what is the difference between these three. Okay, so then what could be the possible interview questions from here? So what is final in Java? What is finally in Java? What is finalize method in Java? So difference between these three things. Okay, so that's all in this video. Thank you. Hi, in this video, we'll talk about user-defined exceptions. So what is user-defined exception? How we can create that, we will see with one example in this. So sometimes we need to create our own exceptions to meet the programming requirements. These exceptions are called user-defined exceptions or customized exceptions. Okay, so as part of exceptions, we already saw so many exceptions in our previous videos. That is checked exception, unchecked exception, so interrupted exception, IO exception, arithmetic exception, null pointer exception, SQL exception. So many are there inbuilt in Java. So that we saw, but sometimes those are not sufficient. We need to create our own exception. So that time, how you can do that? Okay, so for example, insufficient funds exception. So you are developing a banking related application. If somebody tries to withdraw some money, so you need to mention, you need to say that customer that insufficient funds exception, you have to raise that. So daily limit crossed exception. So in a daily, I need a customer can withdraw only 10,000. If he try to withdraw more than that, you need to throw an exception. So how you can implement all those things? So with the help of an example, we'll discuss. Let me go to Visual Studio Code. So here I created one class called user defined exceptions example. Okay, so now, so I'll try to write an exception for daily limit crossed exception. Okay, so first system.out.println. So I'm giving one instruction, please enter withdraw money. So user has to give some amount. So then I'll use scanner class. Scanner SC is equals to new scanner of system.in. So for the scanner, we need to import java.util.star package. Okay. Now int amount is equals to sc.next int. Okay. So now I'll write the logic. If amount is greater than 10,000. Okay. If amount is greater than 10,000, I need to throw one exception. Throw. What is that exception? New daily limit cross exception. Okay. I want to throw this exception, that is user defined, my own exception. Okay. I want to give some information to the customer. So how you will implement? So first, if I want to do this one, I need to create this exception, and it should be of throwable type or exception type or any exception type, right? So for that, what I'll do, I'll create a class daily limit cross exception. Inside this, I will create a constructor for this, and here this is parameterized constructor. I'll give one string str. So now it should be of type throwable, right? So then I will extends throwable. Okay, and I'll call super class constructor. Okay, we already saw what is the super keyword. It will call super class. This is throwable call constructor. So I'm passing the information to that. Okay, so this is parameterized constructor. So if it is parameterized constructor, if I am using here, I can provide some parameter in the form of string, right? That is what is it is accepting. Now I'll give the meaningful information to the user. What is that? You withdrawn, sorry, what I'll put, you are trying to withdraw more than the daily limit. Okay, more than the daily limit. Please check before you withdraw. Okay, so this is what information I want to give. Okay, so let me make it 2 lines. Yeah. So now what I'm giving information to the user, you are trying to withdraw more than the daily limit. Please check before you withdraw. Otherwise, sorry. Otherwise, system.out.println. As I'll give one information like you withdrawn your money successfully. Enjoy the day, something like that. Right, this is what I display to the user. Now if you try to execute this, right, if this is more than that, I cannot raise interrupted exception, I cannot throw IO exception, I cannot throw arithmetic exception, right? So to fulfill my purpose, I created my own exception, class daily limit crossed exception. It is the child class of throwable now. So I created one constructor and it is calling superclass constructor, that is from the throwable. Okay, so because of this is parameter constructor and accepting string, I can give whatever information I want from here. Okay, so go back to here. So I'll try to compile this. What is that? I think let it be in single line. User defined exceptions example, please check this. Unreported exception daily. Right. Why it is coming? So what mistake we did? It is saying unreported exception. Okay. So we are throwing an exception, we are not handling. So we need to use throws keyword to handle this, right? So throws daily limit crossed exception. Okay. So now if I try to compile this, so it compiled. So I'll try to execute this. So it is asking, please enter withdraw money. I'll say 5,000. You see that you withdrawn your money successfully, enjoy the day. The reason is there is no exception, 5,000 is within the limit. But if I try to execute the same thing again, now I'll give 15,000. You see that exception in thread main, daily limit crossed exception. You are trying to withdraw more than the daily limit. Please check before you withdraw. Okay. You see, you are trying to withdraw more than the daily limit. Please check before you withdraw. And this is where it is getting in the 9th line. You see that here, right? So we can give our own exception, then we can raise that. Okay, this is how you can create your own exception, right? You need to create that class. It should be of type throwable, and you need to create one constructor of string parameterized, and you need to call the superclass constructor. Use the same thing, you pass whatever information you want to pass to the user. Okay, this is how you can create user defined exception. Okay, so what could be the possible interview questions from here? So what is user defined exception? So if you want to give your own exception, then you can create an exception that is called user defined exception. Explain user defined exception with an example. So which is a daily limit cross exception. So you can create, you can tell this kind of example. Okay. So that's all in this video. Thank you. Hi. In this video, we'll talk about try with resources. So we have seen try, catch, finally, all these things. But what is try with resources? So we'll discuss all these things in this video. So first, until Java 1.6 version, it is recommended to implement finally block to close all resources which are opened as part of try block. Right. So we already saw all these things. So if you using any resource, so you need to close, means you need to release that resource. Otherwise, it will be blocked and other people cannot use effectively. Okay. So if you see that example, so we need to use this finally block to close, right? So close all the resources that are open in the try block. So here you just see an example, try block, open a file. Okay, that is resource. I'm opening a file, means I'm trying to read the data from the data.txt. Okay. So this is BR object we created. So what we need to do in the finally block, we need to release this BR object. Okay, we need to close that. So if BR object is null, not null. Okay, if it is not null, then close that. Okay, this is cleanup code. Right, this is what we are seeing. We saw all these things with few examples also in our previous videos. Okay, try, catch, finally. In the finally block, you will have a cleanup code. If something is opened in the try, we need to close those resources in the finally block. Right. So this is until 1.6 version. This is mandatory. So you need to follow something like this. Okay. So now from 1.6, sorry, if this is the case, what are the observations with this approach? So programmer is responsible to close all open resources. So a programmer has to write finally block and he has to implement the logic to close those resources. So programmer is responsible. So it decreases the readability of the code as we need to write more code, that is need to implement finally block explicitly. So it looks like we need to write this finally block extra code and the readability will be very low. And so what we are saying, we need to implement finally block explicitly. We need to write this block to release the resources, right? But to simplify these things, whatever we have done, try, catch, finally block, all these things, to simplify these things, Java introduced a new concept called try with resources in Java 1.7 version. So that is what we are going to discuss, try with resources. So what is the advantage when you use try with resources? How the syntax will be, all these things we'll see. So try with resource statement automatically closes all the resources at the end of the statement. A resource is an object to be closed at the end of the program. So if you opened any connection to the database or any you're interacting with any file, so that will be closed automatically at the end of the statement, right? So that is the advantage, means you no need to write the finally block to release the resources. Okay, that is the advantage. You see the syntax will be like this. Okay, so try. So previously when you write try, there is nothing. You just try block means try, open braces, close braces. But here you need to write something like this, try, similar to method kind of. So method parameters, how it will be the same way, try. So whatever you write inside this, normally buffer reader BR is called new buffer reader of new file reader data.txt, we will write where we have written in our previous. You see that inside the try block. The same thing move to next to the try block. Okay, next to the try block as a kind of parameter. Okay, so this way, if you write your syntax or your code, there is no need to write finally block. Okay, no finally block is needed. The moment when it reaches this semicolon, end of this try block, automatically whatever you're using the resources here, the moment when you reach here, everybody will be closed. See, everything will be closed. Okay, not everything will be closed. Okay, so end of the line means end of this try block, everything will be closed. That is automatically. No need to do explicitly or manually using finally block. Finally block is not needed now. With the help of this syntax, try with resources. Okay, that is what. So now, so resources will be closed automatically once the control reaches end of the try block, either normally or abnormally. If inside the try block, what happens? Whatever it is. But the moment when it reaches the end of this try block, all the resources will be released. So programmer is not responsible to close the resources which are open in the try block. That is what we are discussing, right? Try block is not, sorry, finally block is not needed. Programmer is not responsible. Try with resources, the syntax will take care of all those things. It will automatically closes all the resources which we open in the try block. Okay. So readability will be improved as we write less code. That is, no need to implement finally block explicitly, right? So what it is, so instead of this much big code, all these lines, we simplified with only try catch. No need of finally. Okay. So we can declare any number of resources with the try block, but every resource should be separated with semicolon. So here we are using only buffer reader resource, but here only one resource we are using, but that is not restricted. You can use multiple resources. So resource 1, resource 2, resource 3, something like that. So work with the resources object inside this. Okay, so this is also possible. Now all resources should be auto closable resources. So that is what we are discussing, right? Automatically closes. A resource is said to be auto closable if and only if the corresponding class implements the java.lang.auto closable interface either directly or indirectly, right? So if your class means your class is implements auto closable interface, then it will take care of automatically closing the releasing the resources. So in Java, almost all the classes, what is that input output and this file input stream, output stream, and SQL related, network connected related, all these things are almost everything implements auto closable interface. So because of that, we don't need to bother about all these things, but just know the point. Okay, just to know the point. So all resource references variables are implicitly final, and hence we cannot perform reassignment with the try block. So the moment when you create like this object, this is implicitly declared as final. Okay, so final means we cannot change the value, reassign the value. So you did something like this, and you are pointing to data.txt file. So inside the try block, you try to reassign this to the test.txt, but this is not possible. So can't reassign a value to final variable br, this br. So br is internal final, you cannot reassign that. Okay, so otherwise it will point to two files. So the moment it reaches which file to close, it will not understand. Because of that, they are restricted like that. It will be final. Okay, and now, so until Java 1.6 version, try should be followed by either catch or finally block. But from 1.7 version, we can take only try with resource without catch or finally. Okay, even there is no need of even catch, right? So from Java 1.9 version, we can use already declared objects, that is resources, with try with resources block. You see that previously the entire buffer reader br is called new buffer reader, new file reader, everything we written inside this with the try. Okay, but you can declare those things outside of the try, and you can use these objects here, try, this object and this object with the semicolon, right? So this is also possible from the Java 1.9. Okay, so let me go to Visual Studio Code. Here normally we'll do like this, right? Try, buffer reader, this one, and you can do this. So if you try to execute this, try with resources example.java. So what it is saying, cannot find symbol, new file reader. So we need what I executed. Why? Yeah. So we need to import java.io package. All right. So if I try to compile now, it should compile. So cannot find symbol br. So the problem is br is what? Kind of local variable kind of. So we need to do outside this and use that. So otherwise, the moment it comes here, it will become null. If it is not null, then close. It's already null. So we are getting some issues here. I think that is the issue. So let me execute and see my understanding is correct or not. Variable br might not have been initialized. Unreported exception, IO exception must be cut. Okay. Okay. This is IO exception. Right. It is IO exception should handle. What is the problem? Let me look into this. So the issue is error variable br might not have been initialized. So we need to initialize this variable. So because of that, it is throwing an exception here. So it should be initialized as null. Then we re-initialize it here, and we'll try to compile again. So again, the problem, unreported exception, IO exception. So in the finally block also, there might be a chance of raising an exception. That also we need to handle. Okay. So for that, what we can do, throws IO exception. Okay. Throws IO exception, we need to handle. In the try, in the finally also, there is a chance of raising an exception, right? So because of that. So we faced so many issues here. So, but okay, we understand what exactly we are doing. Because of that only we are using Visual Studio Code. We'll do some mistakes, we'll understand. If it is Eclipse or something else, so it will show there then and there itself. So we'll not understand these concepts properly. So now, this is normal try catch finally, but we are talking about try with resources, right? So we need to move this code, right? We need to move this code to here. So this buffer reader, Control X, this one, and then I'll remove this line, and we don't need this, right? We are simplifying the code. We don't need even finally block. That is what, right, we are discussing. So no need of finally block, and remove this. So the code became very small, means a less number of code lines. Okay. So if you try to compile this, you see that simply no errors, nothing, no issues, no exceptions. So the moment it reaches here, this br will become close. Br.close, we implement it in the finally block. Here that is not needed. Okay, this one. So what else we discussed? We can put multiple right here. We can put multiple. So how it will be? So here you can put print writer pw is equals to new print writer of some abc.txt, right? Not comma, this is semicolon, right? That is how you need to mention the multiple resources, right? If you try to execute, it should not throw anything. The problem is cannot find symbol. Print writer is coming from where? Let me check this one. I think I did a typo. Print writer, silly mistake. You see that? Nothing. With the, you can put multiple resources like this, and BR and PW will be automatically closed the moment when you reach end of this try block. Okay. So otherwise this BR and PW you need to do manually with the help of finally block, but with the try with resources, this is also not needed. So what we discussed apart from this, so this is 1.7, and we have seen this one just now. So we already saw all these things. So now from the 1.9 version, you can put these things outside of this try and you just pass this variables. Okay. So I'll cut this till here. I'll put outside of this, and let me make it separate lines. Instead of BR, I'll say buffer reader only, so to make it meaningful name. So now what I can do, I can pass this one here, semicolon, and what happened here, print writer. Okay, so this is how. All right, if you try to do the compile this again, I'm getting must be cut, unreported exception, file not found exception. Okay, this is a throwing file not found exception, so let it be kind of exception. If you do now, again try with resources, buffer reader, a new buffer reader, closing here. So unreported exception, file not found exception. Here also unreported exception, file not found exception. Okay. So we moved this outside, we moved out of try block, right? We moved from try block. So here you will get an exception, right? Obviously you'll get an exception. So because of that, we need to throw that exception using throws IO exception, right? If you're using throws IO exception, even I don't need, I think, catch block. Let me comment and verify. So per my knowledge, it should work now. You see that perfectly working, it is compiling. The reason is, so when you get some risky code, that you will move into where try block. But here what we are doing, we moved out of this try block. So then again, we are getting the same issues. We throw it, means we are throwing that IO exception. So if you are throwing like this, we don't need it even try catch, but these resources will be released once it reach this line. Okay, that's how we can manage this try with resources. Okay, but if you put these things inside this, it will become very lengthy and not understandable code. Readability will not be there. So because of that, you can do something like this. Okay, so we saw without catch also, just to try, we are able to work. Okay, now this is all about try with resources. We have seen so many issues and we resolved all those things. Okay, so what could be the possible interview questions from here? So what is try with resources in Java? What is the advantage of try with resources in Java? Okay, so all the resources will be released automatically the moment when you reach end of the try. Okay, that is the biggest advantage. We don't need to maintain the finally block. Okay, that's all in this video. Thank you. Hi, in this video, we'll talk about multi-catch block in Java. So what do you mean by multi-catch block in Java? So Until Java 1.6, multiple exceptions having same handling code, though we have to write a separate catch block for every exception. So you have a try block. Inside the try block, you have risky code. There might be any chance that there might be an exception may raise. So to handle that, we need to write multiple catch blocks that for arithmetic exception, one catch block, IO exception, another catch block, number format exception, another catch block. But the implementation, the handling code is same. Even then also, we need to write multiple catch blocks for each and every exception. So that is for until Java 1.6. It decreases the readability of the code as we need to write more code, need to implement separate catch blocks. Right, that is what we did. So how it will be? So try, so risky code. Okay, so if, one second. So risky code inside the try block. So there might be a chance of arithmetic exception may raise. So then it will handle by this catch block. So if it is null pointer exception, so this catch block will handle. So class cast exception. So then this one. If it is IO exception, this one. So we don't know what kind of exception we may get. So because of that, we need to implement separate catch blocks. And inside this, you just observe, I am printing e.print stack trace. Here also e.print stack trace. For arithmetic exception, for null pointer exception, I am printing just a stack trace. Okay, I'm printing just stack trace. So it will print by default whatever we got, it will print that information. Right, we are not doing anything manually. Here, for the class cast exception and IO exception, we are just printing e.get message. So in both the exceptions, we are just printing the message. But the implementation is same code here also, and here also the same code. All right. So this is what, even then also, here also same code. Even then also we need to write multiple catch blocks. Right. So that is until 1.6 Java version. Now to simplify this, Java introduced a new concept called multi-catch block in Java 1.7 version. So the main advantage of multi-catch block is we can write a single catch block which can handle multiple different exceptions which are providing same kind of handling code. Right, same type of handling code, then why to write multiple catch blocks? That is handled here. So how the syntax will be? So try as it is risky code. But if this is common, if this code is common, handling code is common, then arithmetic exception or null pointer exception. Right, arithmetic exception or null pointer exception. So you can mention this or pipe symbol. Then we clubbed 2 into 1, 2 catch blocks into 1. It might be 3 catch blocks, 4 catch blocks, whatever it is. But if you are throwing the same message, same handling code, if this class cast exception, IO exception also means printing the e.print stack trace, you can move these 2 also here by putting pipe symbol. Okay. But this is different, just for the sake of example. So these both are printing just e.get message. So here we are using pipe symbol and maintaining only one catch block for these 2 exceptions. Okay. So there is no rule that only 2 will be there, multiple if the handling code is same. Okay. So this is the advantage when you use this multi-catch block in from 1.7. Okay. So now, the important point is in multi-catch block, there should not be any relation between exception types, either child or parent to child or same type. Otherwise, we will get compile time error. So what it is saying is, so I'm using arithmetic exception or I'm mentioning exception. So arithmetic exception is child of exception, right? So if you mention like this, exception will handle this arithmetic also. Then why to mention arithmetic exception explicitly? So this is not possible. You let compile time error. Okay. So order might be different. Here IO exception, here arithmetic exception, whatever it is. So these should not be of any relation. Means here we have child parent relationship. Exception is parent of arithmetic. Even exception will handle the arithmetic exception. then why to mention arithmetic exception explicitly, right? This combination will not work. The same way, IY exception, IY exception. So it's become duplicate. This is also not possible. So one time is enough. Okay. So this is important point we need to remember. So let me clear this. So let me go to Visual Studio Code and we'll see. I have created one of the classes called multi-catch block example. Here I have written in the try block. So system.out.println 5/0, and I have taken one null string and I'm trying to print here str.null. Here I'll get what? Arithmetic exception. Here I'll get null pointer exception as the string is null. Okay. So in this case, if I try to execute this, so first it will come here, you will get the exception. So it will search for the respective arithmetic exception catch block. You see that here. Okay. So in that case, so it will handle from this catch block. Okay. So let me execute this. So let me take this Java C. I'll compile first. Say nothing. I'll execute. You see that it is printing system.out.println E division by 0 arithmetic exception. It is printing. So this catch block is handling. Okay. So now I'll comment this. This time it will come what? Null pointer exception. It will search for the any catch block, respective catch block. So let me compile this. Let me run this. You see that null pointer exception, it is printing. Okay. So, but here we are writing two catch blocks, but the implementation is same. I'm just printing the E. So instead of like this, we can club. Okay. Using the pipe symbol or multi catch block here, and I'll remove this. Okay. And I'll put it back. We'll try to, the moment when it comes, it will find the arithmetic exception. So here we are handling, so it will print. So let me compile this again. So compile, execute. You see that same division by 0. The reason is it came here in the catch. So it is able to handle because we are using arithmetic exception. Okay. So if I comment this, if I try to compile now, so compile, if I try to execute now, you see that same information, null pointer exception. So then no need to write two separate catch blocks. One catch block with this R symbol, pipe symbol is enough. So the moment it comes, whether anything is matching with this exception, so it will take care of that. So we decreased our code and readability improved. Okay. So this is how you can use. And we are talking about something, relation should not be there. I'll say exception here. Okay. Exception, and I'll remove this. So automatically arithmetic exception, it will try here. So, but here exception, arithmetic exception, both will handle this one. So why two? Right. So let me compile this. You see that alternative in a multi-catch statement cannot be related by subclassing. So arithmetic exception is a subclass of alternative exception, clearly mentioning that. So no need to do this one. And if you take the duplicate, okay, if you take the duplicate, even then also it will say the same thing. You see that arithmetic is a subclass of alternative arithmetic exception. So there should not be any relation. It should not be same, or there should not be any parent-child relationship. So because it should be null pointer exception only. Okay. This is how you can manage multi-catch block. Okay. So what could be the possible interview questions from here? So what is multi-catch block in Java? What is the advantage of multi-catch block in Java? Okay. So that's all in this video. Thank you.